Bismillahirrahmanirrahim. In this video, we are going to implement 9 machine learning projects. So our first project will be news article recommendation system. By implementing this project, you will be able to know how to work with recommendation system and how to implement different recommendation system types. Our second project will be customer segmentation using Kmeans. By using this project, you will be able to know how to work with unlabeled data, or you can say unsupervised learning problem. Project number 3, chronic kidney disease predictor system. By using and working with this project, you will be able to know how to work with classification problem. Or price predictor. So here you will be able to see how to implement and how to work with regression problem. And our project will be crop recommendation system. So here you will be able to see that how you can convert classification problem into a recommendation system. Project number 6, crop yield predictor. So again, here we will use the same crop prediction or crop types of data set, but we will be converting that problem into a regression problem. So here we will focus on continuous value. Movie recommendation system. So here, by implementing this project, you will be able to see how you can use a movie or how you can create a movie recommendation system, but search based. Like if you search a movie in a title, then it will recommend top movies. Sentence pair relationship. By working with this project, you will be able to how to work with textual data. But the main idea that you will be able to know by using this project that how to classify a pair of sentences or a pair of sequences. Career aspiration predicted. So here again we will use a classification problem by some input, and we will see that how we can predict a career for a student based on input features. Now, as you know, in machine learning we have a workflow for each project. Like data loading, the second step is data pre-processing, like data cleaning, and the third step is train test plate. Then you train a model, then you evaluate a model, then you deploy that model with some UI or website or app. So this is the basic and main workflow for any machine learning project, but here in some projects you will see a different workflow based on that domain. So the prerequisite is, if you are watching this video, then by implementing all this project, you must have installed VS Code or PyCharm on your computer, and you must have some basic knowledge related to machine learning and Python basics, but you must have intermediate or maybe advanced knowledge with Scikit-Learn. And the good part is that we have a lot of courses related to Scikit-Learn on this course, on this channel. And you must have some basic knowledge with Flask and Streamlit frameworks that are used for creating UI and backends. Okay, but if you still don't know about all these prerequisites, then we have also implemented as a beginner in each project. So now let's get started. So in this video, we are going to implement an end-to-end recommendation system project, a news article recommendation system using content-based recommendation system, collaborative filtering, and hybrid-based recommendation system. For this problem, we have used Mind News Articles data set, and we have also created this user interface where you can pass user ID and user search. So let's say I am new user for this platform. This is my ID and this is my search. So basically I am interested to find out how to save money. So I'm going to find out some articles, news articles for how to save money. So the moment I click on this button, let me pause and let me click on this button. So these are the recommendation. 17 moves that will make or save your money. So as you can see, this article is more similar to my search. 23 ways you are wasting money. As you can see, again it is similar for my search. This is also similar. So you can see we are getting more similar recommendation based on our ID and search. Let me try one more. Okay, let's say we have this user with this ID, and let's say the user wants top investment strategies in 2024. Okay, so let me make it accurate investment. Yeah, so here this is the ID and this is the search of user, and the moment you click on this get recommendation, we are getting more similar recommendation. China's hottest investment or price sneakers. Again, it's almost similar to our search for this user. 5 medium risk investment, again similar. UBS tightness investment, again similar. So you can clearly see we are getting more similar news articles, and once you click on this button you will be able to read that. So before deployment and before creating user interface and backend, we need to explore the data set, and we need to implement all 3 recommendations using this Jupyter notebook. So we will be using this mind small data set for news article. You can get or collect or download this data set from this link from Kaggle. Since I have already cleaned and pre-processed that data, so we will use content-based recommendation, collaborative filtering, hybrid-based recommendation system. Then we will create a user interface with backend. So first thing first, you need to load the data set. So this is the data, merge df. Once you click on this link, you will be able to get the data and download from there. So let me run it and let's see. This is the data. Before proceeding, you need to understand this data set. In this data, we have news ID. For each news article, we have a specific ID. That news category. So since the original data is quite big with a lot of category, but since I have filtered only financial data, so you'll get mostly financial category, okay, and you'll get some subcategory. This is the title, where news article title. This is the abstraction, where you have a lot of text for each news. URL, title entities, abstract entities, user ID, clicked, and content. Basically, I have created this content. Now, since we are going to implement content-based recommendation system, and content-based recommendation system needs tags and keywords for each news article. So content-based needs metadata like category, subcategory, title, abstract. So what I have done, while cleaning the data set, I have created a new column by the name of content while merging this category, subcategory, title, abstract. So for each document, I have a new content column where I have category, subcategory, title, and abstract, because this will give me tags, metadata, or keywords for similarity with other documents. And we have done this for all the news articles. How you can do that? You can basically implement this code. You can create a new column like content, and then you can combine by calling title with some space, and then by calling abstract column with some space, and then by calling category. So yeah, in that way you can create a new document for each content by merging title, abstract, category. Okay, this is the way. Now finally, we have this column which is quite important for content-based recommendation system. So what will happen? We need to create a vector, a numerical representation for each document. So you have to import TF-ID vectorizer from feature extraction.text class. So this is TF-ID vectorizer. That is basically used to transform your data into a numerical format or vectorized format. Then you have to create an object like vectorizer. Then you have to call TF-ID vectorizer. Now here you have to pass couple of parameters. We don't need English stoppers. You can remove them explicitly. and there is another parameter max df, so I am going to use 80% data as a max df, and min df I'll use 50%. Okay, so you can use this parameter. And then there is another parameter n-gram range, so you can use unigram and bigram. You can also calculate at the same time two words, and we have seen all these things in detail in this sample list. Now you have to apply this vectorizer on your column by calling fit transform method. So since we have merged df where we have this content, and I can say tf-idf matrix. Now you will get a vectorizer form for each document. So if I just show tf-id vectorizer, that how it looks like, as you can see, you will get a vector for each document. This is the first vector for this document, and for this document we have second vector, and in each list or each vector you will get some numbers. If you are getting higher number, it's mean that word is important for that entire data. If you are getting some zero, then it's mean that word is not important. Okay, but yeah, this is the form. Now we have to calculate cosine similarity of each vector. Let's say for this document or for this vector, we have to calculate cosine similarity with all other documents, and for the same things goes for second document. So what will happen for second document? You have to calculate cosine similarity score with first document and all the other document, and then for third document, fourth, fifth, up to so on. So what you can do, you can call from Scikit-Learn dot matrices dot pairwise, you can call cosine similarity class, and here you can say cosine similarity, and then you can call cosine similarity class like this, and here you can pass tf-idf matrix 2 times, because we are going to calculate each document or each vector with all the other. So if I just show this new cosine similarity, you will get again a list, but this is important. Each list represent each document similarity scores with all other documents. This is the list for first document, similarity scores with all other documents. So first document similarity score with itself, which is 100. First document similarity score with second, which is 0 point something. First document similarity score with second one, with third one, fourth one, up to so on. If you are getting higher score, let's say 90, 95, 0.90, 0.95, it's mean that the first document is more similar to that document. Now again we have another list where you have again similarity scores, but this is for second document. So here second document similarity score with first one, second document similarity score with itself, which is 100, second document similarity score with third document, with fourth, up to so on, and then third document, fourth document, fifth, up to so on with all the remaining documents. Okay, this is important, you need to understand. That's it, that's your content base. Now before creating a recommendation system, let me create a new title where user is interested. Okay, this is the new article where user has searched. Now first you need to clean this title. So title will be equal to, like, we can use a regular expression. So import regular expression module. So first we can remove special character by using regular expression subtract method with this pattern. Okay, this is the pattern. Forwards backward slash w plus, this is the symbol that is used to remove special characters from your text, and we are going to replace with empty string from this title. So let me add some special character, and if I just show title, as you can see we have removed. One more thing, you have to also bring all letters into lowercase. So here you can call title dot lower, and you can also remove extra spaces. Let's say if I remove some extra spaces, then you can call strip method. So now you can see we have removed extra spaces, we remove special characters. So our cleaning phase is done. Now we have to create a vector by using the train vectorizer by calling transform method, and here you have to pass this title. So you can give it a name title vector. So if I just show title vector, you have to call to array function. Now we have a vectorizer form for this title. Now we can calculate cosine similarity for this new title vector with all the other vectors in our database. So cosine similarity, and here we can pass title vector and or this TF-IDF matrix, okay, in real time. Since it will return 2D, but I am interested in single D, so you can use flatten, and this will be or you can say cosine scores like this. So if I just show you cosine scores, so here it's mean for this new title we have calculated cosine similarity score with all document. You document 1, we document 2, we document 3, but I am going to get top 5. So I can assort in descending order, and then I can fetch top 5. These are the top 5 similarity score. Now here you can see 0. This is not 0, this is 0 point something. It will be 0.95, it will be 0.98, or it may be 0.91 or 92 or 72 or 78, okay? But I'm not going to get the exact cosine similarity score. I'm interested in its index. So I can use argument sort method like this. Now you will get proper IDs of that news, and this will be my indices. Now based on this indices, I can fetch proper recommendation from my data set. So my March df dot location, based on this indices, I am going to fetch news ID column, news title, news category. So let me run it. There is a little bit issue. News ID. Let me check. Okay, spelling mistake. It's basically news ID. So let me paste here news ID. So as you can see, these are the top 5 recommendation for this new title. You can also return subcategory URL if you want, but instead of this we need to create a proper function that will get new title, then it will do cleaning, transforming, cosine similarity and recommendation. Okay, so here we go. This is the function by the name of content based recommendation. It has some parameter like title and top 10 5. Then we are doing the same code, exactly the same code. So here we have called this function by passing this new news article title, and we are fetching top 5 recommendation. Let me add a new cell, and here I have passed some other title, and we are also getting recommendation. So that was content based recommendation system, where basically we use metadata for similarity. Now let's create collaborative filtering. Now collaborative filtering is very important. Collaborative filtering basically needs, if I just call column, sorry, it should be merge here. Collaborative filtering needs 3 columns: news ID, user ID and rating. But since we don't have rating, we have clicked them. So what you can do, you can create a user item matrix. So let me create user item matrix. How you can create? You can call merge df by calling pivot table. This is quite interesting. Let me just implement On index, basically you pass news ID, and on columns you basically pass what do you pass basically, sorry, here it must be user ID, okay, and on column you pass news ID, and on values you pass rating or clicked. Since we don't have rating, we have clicked. And yeah, if I just show user item matrix, you will see this matrix. So it will also return a lot of non values. You can fill that values by calling fill values with 0 or any value. But yeah, this is the new DF which is known as user item matrix, where on index you will be see users, these are users item, and for column you will see items or basically the news. Now for each user you will get this list where you will have ratings or clicks of that user for each news. So this user, for this news, this user has no click. This user has no click for this news. And but yeah, you will also see if we take this user, this is another user, and it has one click for this news. Okay, so we have created for each user user item matrix, where on index you will see user, on column you will see news, and for value you will see clicks. If that user has no clicks, then you will get 0. If the user has some click, let's say this user has clicked this news 5 times, so you will get 5 right here. Now we have to calculate each user with all other user similarity score. That is known as user item similarity or collaborative filtering. Okay, but before that I would like to transform, since this is a string, these IDs are string, we need to properly convert them into numbers. So for that you can import basically from Scikit-Learn dot preprocessing, you can import label encoder. Okay, label encoder. Now I will create 2 encoder. One will be user encoder, here I'll call this encoder, and one will be item encoder, or let's say news encoder. Okay, now I will apply this encoder on both data. So the first one is news user ID. So here, sorry, this will be a new column, user encoded. Okay, and then I'll just call user encoder dot fit transform method by passing my user ID column. And let me also do the same for, so here we go. What happened? Basically we created 2 encoder for user column, user ID column, and news ID column. Then we have transformed news ID, user ID and news ID by creating new column. Okay, if I just pass this code, and if I just remove this code from here, and if I just display the new data, as you can see, news ID, these are string, but you will see new column, news ID, but now we have properly string, and the same thing goes for user in. And accordingly, now we can create user item matrix by using this code, pivot table, but this time we have used user encoder, news encoder, other things are similar. Once we create this user item matrix, then we calculated similarity score by passing user item matrix, and this is the final matrix, user similarity. So for each user you will get a list in the same way like previously, similarity of user 1 with itself, similarity of user 1 with second user, similarity of user 1 with third, and up to so on. User 2 similarity with user 1, user 2 similarity with user 2, user 2 similarity with user 3, and so on. Okay, now we can create a recommendation system. So here I can create a function by the name of collaborative base rec. It will get input user. This will be a new user ID, our data, and default parameter with top 5k. First thing first, since this is a new user, so we have to apply this user encoder. So user encoder dot transform this input user ID, and it will be user index, like this. Second thing, get similarity score for this new user with all the other user. So since we have already a matrix user similarity, basically this one, you can just pass this new user index, and this will be scores. Users scores are just, you can give this name like similarity score. Okay, now we have similarity score for this new user with all the other users. So next we have 3 steps. First, we will get all the clicked news article that are clicked by this users. So since we have already user item matrix, so we can call that user item matrix, and then we can call iloc, and then we can pass this user index, and it will fetch us all the clicked items by this user. User clicked news, or you can say items. You can change that variable names as it is, but yeah, let me pass this code. Now we have user clicks. So after that, since we have user index, user similarity score with all other users, and user clicks items, then we have calculated sum of clicks by similarity score. So what we can do, we can use similarity scores with this static, and then we can get all the other users values, and it will give us weighted score. After that, we have removed already clicked items from recommendation using this filtering techniques. Just we replaced with 0. That's the code, guys. Now we can only get top 5 recommendation. So basically you can use weighted. Finally we have this. You can use the same argument sort method like this, and you can sort in descending order, and then you can fetch top 5, or you can directly pass top 10. Okay, and then you can say these are the top news indices. Okay, now based on these indices you can fetch your data. So what we can do, so since we fetched the top news indices, top 5 news indices, but we need to properly convert them back into their original form, because we have encoded these IDs. So we have to bring them into original form, from this form to this form. So since we have already trained item encoder, you can use inverse transform method, and here you can use top news indices. Okay, so yeah, this is the code. And finally you have this recommended news IDs. These are the top 5 news IDs in original form. Now let's filter out the data for this news IDs. So basically we can filter in the way like go to df, and here we have news ID. Now here we have quite interesting method, that is in, and based on this recommended indices, fetch all the top 5 records, which could be news ID, title, category, URL, and so on. So finally we have this code, guys. So this is the function that is basically getting new user ID. Here we are transforming that ID, then calculating similarity for this new user with all the other users, then we are getting clicked item by this users, then we are getting weighted sums or weighted score, and then we are getting top 5 recommendation indices. Since this will be a transform version, but we are fetching their original version by using inverse transform, and then we are getting top 5 recommendation. So here we have called this function, okay, we have called this function collaborative filtering, and we have passed new user ID and our merge df. So if I just run it, so for this user we are getting the recommendation based on similarity score or collaborative filtering. Perfect. Now final hybrid based recommendation system. This is quite simple. Hybrid based recommendation system is basically going to use combination of these two functions. It basically use combination of collaborative filtering and content based recommendation system. So here let me quickly paste this code, which is quite simple code. So here we have a function by the name of hybrid recommendation. Now in hybrid recommendation you have to pass two things for new user ID, the title, your database, and top recommendation. In this function first we have cleaned in the same way the new title. Then we have within this function we have called the above function, which is content based rec, and we have passed title, and that function is used to return a df of top 5 recommended item based on metadata, and these are the result. Then we have called collaborative filtering by passing user ID, and we have again fetched the results. So now since we have mentioned that hybrid recommendation is used to combine the results of content based recommendation and collaborative, so here we have used pd.concat function, and we have combined the results, and we have also dropped the duplicates, and we have also reset the index. Finally we have these results, and we have fetched top 5, and we are returning. So here we have called hybrid recommendation by passing new user ID, new user search, and our database, and once you run it you will get for this user and this search this recommendation. That's the flow. That's the original flow of any type of recommendation system. Now we will use this same code, hybrid recommendation, content based function, this code, this content base, and this code in our app.py file. Now let's create proper user interface and backend. Okay, so you need to open any IDE like VS Code or PyCharm, and here you must have templates folder. So you have to click on your external folder, go to new, and create directory, and the name must be same like templates, because we are going to use Flask framework for this project. And within this template you need to create a HTML file by the name of index.html, as you can see, and you must have Python file where we will be implementing backend code, which is this one, app.py. Now first thing first, go to your terminal and you need to install pip install Flask, Scikit-Learn, pandas, and you need to install these 3 libraries. Since I have already installed, so once you click and enter, it will be installed. Okay, now from Flask I'll import couple of things. Capital F Flask, which is used for creating application, render template, which is used for redirecting to index.html file from backend, and request. Okay, then we need to create, we also need to create app. So here you have to call Flask with this built-in syntax. Okay, and then we have to create Python man. So if name equal to man, and then you have to run this app. So this is the basic syntax of Flask that is used for backend as a framework, and here you have to make debugger true. Okay, now between this app and this Python man you have to create rules that will work like bridge between app.py and index.html. Now if you have no idea related to web development or how to structure your web app, but this is the basic syntax. of HTML file where you have some tags. Now within this body we have to create, if I just call div.container, container is basically a class, and here if I just call h1 tag like hybrid recommendation system. Now if I just go to app.py, and here if I just create root. So how to create root? You can create root with this decorator by calling root, and here you pass root path, and then you have to create a function by any name, let's say index, and then you have to return with the help of render template or index.html. So now click right and run app. So it will provide you a URL. You have to click on this URL and it will pop up your app, as you can see. Now since we have not designed this page, we can design, and if I just use a class, bootstrap class, text center, margin top will be 5. These are some built-in classes for bootstrap, and I have also added bootstrap library path. So if I just refresh, now we have in center. Now we will create a form where we have side by side two input fields, one for user ID, second one for search, title search. So here we can use form. Now here instead of action I'll just use post. Sorry, method attribute will be post, and within this form I'll use another div with row, and within this I'll use another div with call md5, md6. These are again bootstrap classes. Okay, I'll add it later. Let me add first class or call md6. Now within this div we need two things. First label, it will be id, user id, and input field where type will be number, so type will be text, and here you can pass id like id, and here you can pass name will be id. You can change them accordingly, but now if I just refresh, as you can see we have this id. I'll also copy and paste, and this time instead of id we will have title, and you can accordingly change this to title. So if I just refresh, now we have title. Okay, let me properly add these bootstrap classes to make design properly. Okay, so as you can see we have this container, and within this container we have this h2. Okay, let me make things proper like this, and then we have form. Within form we have this row div, within row we have two input fields. Okay, and here I'll also add another bootstrap class, that is margin top will be 5. So now if I just go and refresh, we have this proper form where we have two fields. Now here I will add a button. So right after this div, before form, you can add this code. So again we have this button, this div with text center, margin top will be 3, and this is the button by the name of submit with this bootstrap classes. Okay, so if I just refresh, we have this button. Now once you type here title, id and title, and click on this button, we need to fetch with the help of this name which is user id and this name which is title right here. So here in this root I can say if okay, one thing more here, I have to add methods post and get. Once you pass data between front end which is index.html and back end which is app.py, then you have to use this post and get. So here I'll call request dot method. If it is equal to post, then you have to proceed and you have to fetch user ID by calling a request dot form, and here you have to pass exactly that name that you have used, which is user ID. Sorry, user ID, and let me control D like this, and here we have title. So if I just print user ID and title, and if I just refresh, and now let me pass this ID and let me enter, and if I just go to my run, as you can see we are fetching details. Now we have to pass this detail to hybrid recommendation function. So let me call hybrid recommendation that will get user ID and title. Now we must have this function as we have already implemented in Jupyter Notebook. So let me open Jupyter Notebook right here. This is the notebook that we have already. So here I'll copy this code, Control C, and go to app.py. Let me zoom out a bit, and here let me add a comment recommendation by pasting this code, and then let me copy exact this function, content base, because hybrid internally need this function. Okay, and let me paste it right here, since we also need to load this data. So right here I can call merged df, then I can call pd.read csv, and I can pass merged df.csv. So let me also import pandas as pd, let me also import regular expression, let me also import from sk done.feature extraction.text, I need to import tfid vectorizer, and from Scikit-Learn matrices pairwise we also need to import cosine similarity because we have already used them. Okay, and now let me also copy paste content base, collaborative filtering. So I need this code, I need this function, and I also need this function. Okay, now try to understand this code. Basically we have this root where we are getting user ID and title. Now what will happen, I'll paste this code. Here I have called hybrid recommendation function by passing user ID, title, merge df. Now since we are also going to display this result on this index.html page, so I explicitly converted into dictionary, and then I have called index.html by passing my recommendation. Now finally we will display this results right here. But before that, we have this content-based recommendation function, the same that we have used in Jupyter Notebook. And since this function also need content-based and collaborative filtering, so here we have the same collaborative filtering and same content-based with all the pre-processing like creating user matrix and all those things. Okay, perfect. Now we only need to display this result right after this form. Okay, so what we can do here, we can use Python code with Jinja template. First we will check once user click on this button, and once we get results, which is recommendation right here, then we need to check if recommendations with this syntax, and you also need to and if. This recommendation means is basically this variable. Okay, so once we get recommendation from backend right here, then we need to display them. For now, just let me quickly display this recommendations with this syntax. You have to use exactly this syntax. Now let me go to app.py and let me rerun the app. So it will provide me the link again. Okay. So let me open the app. So it's loading. So here we go. Now let me quickly give this user ID and this title, and let me get click. As you can see, we are fetching the result, but this is a dictionary where we have news ID, title for top 5 recommendation. So we have to properly display. Now for displaying properly, what you have to do, you have to use this code right here. You have to use this code. Okay. Basically, let me remove everything and let me paste this code. So here first we have checked if recommendation, then I need this bootstrap class so that I can display properly result, and then I have run loop for on this recommendation because we are getting top 5 rows, top 5 recommendation. So this will fetch first row, and then I'm displaying that recommendation title, that recommendation category, and abstract, and also URL. So basically we are displaying 5 recommendation. So now if I just refresh, as you can see, we are properly displaying this 5 recommendation. Let me try one more. This one, how to save money. As you can see, we are fetching result. Implementing an end-to-end customer segmentation project using our first unsupervised learning algorithm, which is known as Kmeans. So this video is dedicated to all those students who want to learn an end-to-end implementation for unsupervised learning, especially customer segmentation for market or a multi-type data set. So before discussing everything, this is the basic user interface where you will give for new user its gender, like the user is male or female, let's say female, and here you have to set that user age, annual income, and spending score. Okay, let's say we have a user, let's say he is young with 22 years of age with low annual income. Let's say he has very low annual income, and let's say his spending score is also lower. So we have a new customer that is female, which is young with a low annual income, with low spending score. Now let's see what our trend model, which is Kmeans, tell us about that user, and which group or cluster it adds that user. So let's see. So our model is predicted segment for this customer that it has a low income and low spending. Okay, segment is low income and low spending. Let's say we have another user which is male and he's young with high annual income and a high spending score. So the moment you click on this button, as you can see, the segment high income, high spending. But let's say there is another user which is male, which is again young but low income but high spending. So this time the segment is that it is young but low income and high spending, as you can see. So you can clearly see the model is quite interestingly create segmentation or generate segmentation for any type of customer based on its input like gender, age, annual income, and spending score. So let's discuss and let's start this project. So let's understand our problem statement. So basically we are going to implement an end-to-end project which is customer segmentation using Kmeans algorithm, okay, where we will also be creating a user interface, as you have already seen. Context: this data set is created only for learning purposes, just for customer segmentation concepts, and it is also known as a market basket analysis. And I'll show by using unsupervised ML techniques like Kmeans clustering algorithm in the simplest form. Okay, content. So let's say you are owning a supermarket mall, and through membership cards you have some basic data about your customer like customer ID, age, gender, and annual income and spending score. Spending score could be considered like is something you assign to the customer based on your defined parameter like customer behavior and purchasing data. So you own the mall and you want to understand the customers like who can be easily converge. That will be your target customer. So that the sense can be given to marketing team and plan the strategy accordingly. So you can get the data set from this link that we are going to use in this project. So the problem statement, if you can ask me in simple terms, that we have a market and we want to know daily customers are that are coming in our mall or market. Okay, so we will cluster them, or we will groups them into three classes: low income with low spending. If the customer has low income and they also spend low, then we'll put them into this class. And if we have some customer with high income, high spending, then we will put them into this class. And if we have customers that are young with low income but high spending, and we will put them into this class. And once we get all these customer result, it will be easy for us to make plans and strategy accordingly for our business or mall. Okay, so let's quickly import tools that we are going to implement. So first thing first, always pandas as pd. We also need numpy as np. Since we are going to use unsupervised learning techniques, so from scikit-learn dot cluster we need to import Kmeans clustering algorithm. Okay, like this. And since we are also going to evaluate this model, so from scikit-learn that matrices you need to import Silhote score. Now if it was a classification problem, then definitely you will have used confusion matrix and classification report, and for regression problem accordingly you will have used R2 score and all mean squared errors. Okay, but since this is unsupervised learning problem and we are going to use unsupervised learning algorithm, and if you want to evaluate unsupervised learning algorithm, then this is the best matrix. We will discuss a bit later, but yeah, we also need to visualize finally the generated cluster. So we need matplotlib.pyplot as plt. Okay, so yeah, these are the imports. Now let's load dataset. It should be matplotlib.pyplot. matplotlib.pyplot. Yeah. Now let's load the data set. So this is the data, mall customers. So in this data we have customer ID, that customer gender, customer age, annual income, like 15,000, 16,000, and spending score, which are integer from 1 to 100. Okay, so we are going to use this data set, but first thing first, we need to convert male and female into 0 and 1 because ML model can only understand numbers. So go to gender column and then just call map and then create a dictionary. If we are getting male, then convert it into 1. If we are getting female, then convert it into 0. And let's store it in gender column again. And let me also remove customer ID column. So let me copy because we don't need it. df dot drop columns. You can use a parameter by the name of columns, and here you can pause that column that you want to drop, and here you have to specify that we are going to drop this column wise and permanently, so in place will be true. And now if I just show the data set, you'll be able to see now we have gender with encoded form 0 and 1,
we have age, and we have spending score. We are ready. Now let's train and apply Kmeans algorithm. Kmeans object by calling our Kmeans algorithm, and its take two parameters, number of clusters. For now we are going to use 3 clusters because we are going to generate 3 clusters for our customers, okay, and random stat, which will be 42. But the question is how to know this thing. We will see that a bit later, but if I just call fit predict method by passing my entire data and store the generated cluster into a new column by the name of cluster. So here we go. Let me show you the new df. So now we have new column by the name of cluster. So this is our first customer, and for this customer Kmeans algorithm generated cluster 2. This is another customer, and Kmeans algorithm put it into 0 clusters. So total we have 3 clusters, because here we have defined number of cluster 3. But the question is how we know that. For that basically you use this elbow method. So let me quickly explain you what elbow method is. So the elbow method is a technique used to determine the optimal number of clusters in Kmeans clustering by plotting the inertia. This is inertia basically. So what we do basically, we train our Kmeans 10 times normally. If you train first time, then we plot first inertia. On second training we plot second inertia, and on third training we plot third inertia, and so on. Within cluster sum of squares against K, the elbow point, which is this one basically, you can consider this one. I'll explain. On the graph indicates the K value where adding more cluster yields that diminishing returns. Okay, so basically you can consider it that if you are going downside from a top hill, so your speed will be fast. The moment you reach a plain side, then your speed will become slow. So the moment your speed becomes low, that could be consider your optimal K numbers or your number of clusters. So in this graph 4 would be considered number of cluster. Okay, or you can take it, once you plot this curve and you see your inertia data plots like this, and you get a point from which onward your curve becomes plane, then you can take that point as a number of cluster or optimal number of cluster. I hope you get the main idea. Now let me show you how you can do that. Let me create 2 lists. Okay, one is SSC, one is K range, where I'll define from 1 to 10 times. Okay, so now I will run a loop for K in this K range. So my loop will run 10 times, as you can see. Let me increase it 10 times because I am going to train my model 10 times. And each time I will create an object of Kmeans in the same way, but this time we will define number of clusters with K. Okay, you will understand what will happen. So for the first time we are going to train our Kmeans, and we are setting number of cluster only 1, and for 1 we are going to train Kmeans. So you will pause this, and then we are going to store its inertia in SSE list. How you can calculate inertia? By calling this method. There is a method by the name of inertia. Okay, and if I just run it and print final SSC, you will understand. So as you can see, For each time we are getting some inertia score value. Now you will understand in a more better way if I just plot it. plt dot scatter, and here you have to pass your number of range, which is k, and ssc, which are actually our inertia. Okay, so here we go. As you can see, we have trained our model 10 times, and each time we are plotting its inertia, okay, in this part. So if I just run it, you will see a plot. This is the plot. As you can see, from 1 to 10 we are getting inertia points. So from this plot you can take 4 as optimal number of cluster, because from this point onward we are getting our curve as a plane. Or you can consider from this point until this point our speed was very fast if you take example of top hill, but the moment we reach here our speed becomes slower. So the moment your speed becomes slower, you can take that point as your number of cluster. But for now we can go with 3. You can go with 4, but let's say we are going with 3. So here then you can define separately your Kmeans, and then you can fit predict and create new column, and it will looks like this. So instead of cluster, we can create another column by the name of segment, and we will give proper segment names so that we can understand what we achieved as a final outcome. So I can create a new column by the name of segments, and then I can call my data cluster column, where we have 3 clusters, 0, 1, 2, and here I can call map, and I have this map. If you get 0 cluster, then give it this label. If you get first cluster, then give it this label, and accordingly this label to second cluster, or you can say third cluster. Then we are passing cluster labels right here. So if I just show the new data set, as you can see, here we go. So you can see the age is 20, its income is also lower, its spending is also lower. So cluster is quite great, low income, low spending. But here you can see the person or customer is younger, but annual income is also lower, but spending score is high. So you can see young because he is young, but annual income is lower, so low income, but spending score is higher, and the model is also same, high spending. So we have successfully clusters all customers into 3 groups based on their gender, age, annual income, and spending score. This is quite great. Now if you want to visualize all 3 clusters, that how we actually cluster or Kmeans cluster, you can also do that. So let me create using matplotlib.figure with fig size, let's say 8 inches width and 6 inches height, width and height. So we define our figure. Now we can create scatter plot, and here since we have 3 columns, it's mean we have 3D, we have to generate 3D plot. So we can run a loop for I in df cluster, because we have 3 clusters, so our loop will run 3 times, and here you can call unique, or instead of that you can directly say 3, but for good practices you can do like this. So here we can call unique. So if I just show you, our loop is running 3 times and it's fetching 3 clusters. Okay, and now let's filter out our cluster data. So df, and based on our cluster, if it is equal to I, then filter out and store it in cluster. So we are getting all the 3 cluster data accordingly. Okay, and now we can plot. So scatter, and let's plot all the 3 columns. So cluster, and first column was age, then we have clustered second column was annual. Let me quickly add all. So as you can see, now we have all the clusters. Since for 2D we can for now we are getting just 2 columns. Since this is a 3D, but for now we are getting just 2 columns. You can add other columns as well, but here we have set label as well. So if I just run it, you will be able to see your cluster like this. You can also add title, X and Y. So X label, Y label, title, legends. So if I just run, now you will be able to see all the cluster. Cluster 0 has orange color, cluster 1 green, cluster 2 blue color. So you can clearly see, based on all the data points, our Kmeans algorithm has successfully clustered all the data, our customers, into 3 clusters accordingly. So from plot here you can see we are also getting some overlapping, but still we can go with this recommendation as well. Now final thing, let's evaluate our Kmeans model. So for that you use Segmentation score. It takes 2, your data and your cluster. So we already have cluster. So cluster, but since we don't have this data, let me give it a name features. You can extract that by using these techniques like gender, feature, edge, and so as you can see we have extracted all the columns which are our input features, and we now this is our target column that we have generated with the help of Kmeans. And finally we have calculated Segmentation score and we have printed. So if I just run it, we are getting 0.34. Now if you are getting some from 30 to 50, 60, it means your model is doing a great job. Okay, so here Segmentation score basically measures how similar a point, basically a data point, these are all data points, okay, to its own cluster. Now this is, as you can see, this is a single cluster. So how this point is similar to its own cluster, or how this data point is similar to its own cluster, okay, within the same cluster. And it's also comparing this cluster with this one and this cluster with this one, and based on this it will give this score. Okay, so yeah, you can calculate, you can evaluate your unsupervised learning models in this way. Now since we have more matrices as well, but almost you can always go with Segmentation score. Okay, now let's save our trained model. For that you can use pickle library, because in future you will be integrating that model with user interface or deployment. So you must have that model in a file format. Then you call pickle.dump, and here you can pass your trained model names, and there is a parameter by the name of open, and here you have to give name like Kmeans.pkl. As you can see, I have already saved, but you can save it as well. So Kmeans.pkl with write binary model, and you can also load this model by using pickle. Once you save, you can load it for usage, production usage. .load, and here you can say open, and here you can say the trained model, but this time read binary mode. Okay, so I'm not going to run this cell because I have already or just let me run it. So here we have saved and we have loaded the model. Now before creating user interface and before integrating this model with our user interface, let me quickly give you a real-time customer segmentation function that will exactly follow in app.py or production level. Okay, so yeah, so let's say we have a function by the name of predict, custom Python function by the name of predict customer segment, that will get gender as a parameter, age as a parameter, income as a parameter, spending, score. Okay, this is the data for new customer. So So once we pass this data for new customer, first thing first, since we have trained our Kmeans model on 2D data, so we have to transform this new data into 2D. So what you can do, you can call numpy array, and here you can pass 2D like gender, age, income, spending, score. Okay, and this will be our features like this. Now since we have features, so what we can do, we can basically do prediction, or let's say instead of feature, let me give it a name, new data. Now let's use our train model, which is Kmeans that we have loaded, and this time we are going to predict its class, like low income, high income, young with low income, for this new customer data. So instead of fit or fit predict, you have to just call predict method, and here you have to pass new data, and it will predict either 0 or 1 or 2. So let's give it customer. Sorry, not customer, it should be cluster, yeah, and we will return this cluster. Okay, so as you can see, if I run this predict customer segment, it should be segment method, and here I have called this method by passing gender, which is male, and it has with the age of 28, high income, and or we can say, let's say, low income, and spending score, which is high, which is 60. So if I run, we are getting some error. Spending, I think the error is somewhere here. Spending score, yeah. Unexpected keyword, age, income, spending score. Okay, the issue is, since this is a parameter, and here we have done some spelling mistake, it should be score, because here we have spending score, and accordingly we have to change this to spending score. So we are getting an error. X has 4 features, but Kmeans is expecting 5 features as an input. I think we are passing gender, age, income, spending score. So we have gender, which is gender, age, income. There is an issue because I had used the previous model. So what I have to do, I have to just rerun this code again. It was a minor issue. Okay, so now we have this, and finally we have generated segments, and we have visualized our data, and we have evaluated model, and now we have saved our model. Okay, so now if I just run this code, this, as you can see, we are getting 2, which is the cluster actually. So what I can do, I can create a mapping, sorry, not this. Since instead of displaying 2, we have to display proper message or the label or class, so we must have some mapping labels. So here we have created a dictionary with key 0, label this, key 1, label this, and here once we get the cluster, which is 2, we have to extract, based on this 2, we have to extract this message. So what you can do, you can call this cluster labels, and here you can call get method, and here you can pass predicted cluster. If it's return nothing, then you can return default thing like unknown cluster. Okay, but yes, it will get if we are getting some cluster right here like 0, 1 or 2, then from this cluster labels we must have some message, and this will be our segment. So here we are returning, instead of returning, just let me print both cluster and segment. So as you can see, finally we are printing a cluster and segment. So if I run this cell, so here we have called the function by passing a new customer data, and it's predicted to which is young with low income but high spending. I have called the same function second time, but this time I have passed female, younger, with low income, low spending. So the moment I run, it's predicting low income, low spending. So it's mean our model is working. Now let's quickly create a user interface. So I have opened IDE, which is PyCharm. You can use VS Code or any IDE which are suitable for you. So first thing first, import. Since we are going to use Streamlit library for creating user interface and this app, so you need to import Streamlit as st, and we also need to import NumPy as np, and we also need to import pickle because we are also going to load the save model. And as you can see, I have this save model right here. So load model, which is Kmeans, you can say pickle dot load open Kmeans with read binary mode. And yeah, now let's quickly create okay, first go to your terminal and you need to install few things. Like here you need to install Streamlit, NumPy, Scikit-Learn. The moment you enter, it will be installed. Since I have already installed, so I'm not going to reinstall, but yes, you have to install all these three libraries, okay, like Streamlit, NumPy, and because Kmeans is trained that internally using Scikit-Learn, so you must have Scikit-Learn, okay. So what I can do, I can paste this code right here. We have Streamlit, pickle, NumPy, then we have loaded the train model. This is the cluster labels dictionary that we have already seen. Now let's quickly create UI. So I can say Streamlit.title, and here I can say customer segmentation. You can add some markdown like this. Input new customer, age, gender, income, spending score. Now let's view the app. So what you can do, you can go to your terminal and here you can say Streamlit run app.py. The moment you enter, your user interface will be popped up in your Chrome browser, okay. So you will be able to see your UI quickly. As you can see, we have this UI. So what I can do, so I have quickly designed everything. So here you can see I have add another function provided by Streamlit library, set page config. It will make your page like page title directly, layout will be centered, your entire page will be in center. Then we have this title and this markdown. So now if I just go to my page and just refresh it, you will see everything in centered with proper title and markdown, okay. So it's loading. As you can see, now we have everything in center. Now I will add here a sidebar where we will take input from user. So what you can do, right after this we can add sidebar. So Streamlit.sidebar.subheader, and here you can say customer new customer input. You can change it accordingly, but if I just refresh, as you can see, now we have proper sidebar. Now we can get input from user, okay. So let me make things like this. So let me zoom in a bit. So yeah, first let's get age, sorry, gender, And here we can say that st.sidebar dot radio, we can use a radio function, and here we can say gender, and here you can pass a tuple like male or female, and here we can also directly encode the gender by saying that if gender equal to male, then return 1, else return 0. Okay, so finally we will have 1 and 0. Second input is age. So again st dot sidebar, and here you can use slider, like we can use slider, and here we can say age, and here you can assign range. Let me quickly do for all inputs. So what I can do, I can paste this code right here. We have sidebar with header, and then we have gender, and we have also encoded dynamically. Then we have pass 3 slider for age, income, score accordingly. Now let me also add here a button. If someone add all these input and then click on st.sidebar.button like segment customer like this, then we will do using the train model segmentation. But for now let me make it pass. So what I can do, I can just refresh the page so that we can see. As you can see, now we have everything right here. So what we can do, so from this on click on this button, the code is pretty much similar. So what I can do, as you can see, if someone click on the button like predict segment, what we are doing exactly the same thing that we have done in the real-time prediction or generation system. First we are creating 2D input data, then we are predicting cluster, then we are getting the label for the predicted cluster, which is segment, and then we are predicting success using success method and info method accordingly, segment and cluster. And here I have created a color map for each cluster, and accordingly I have used CSS. And if you are going to use CSS within Streamlit library, then you have to use markdown with this code, and accordingly we have printed. And I have also added this logic as well. This is quite simple, you can explore, but yeah, finally our code is ready. So just let me quickly show you that how it works. Or before that, let me give you an overview. As you can see, we are loading Streamlit NumPy, we are loading the train model, we have created our mapping labels, these are the titles, this is the entire sidebar. Okay, this is the entire sidebar where we have some header, and we are getting all the 4 inputs for the new customer. And once someone click on this button, then we are doing like creating 2D prediction, generating segment, and then we are printing things accordingly. Optionally we are adding some CSS for better visualization, and this is the footer. Okay, so let's refresh. So initially you can see we have nothing, but if you select a new customer, let's say we have a customer which is quite old, which is female with a high annual income and low score. Okay, and the age is, I don't know why it's not updating, but let me predict. So high income, high spending, as you can see, 63 age, 109 annual income, 88 spending score. But if we have some younger customer with low income, low spending, we will get results something like low income and low spending. So just let me quickly give you the objective of this video. So here you have to pass patient medical features like patient age, patient hypertension value, like the patient has hypertension or not. So let's say yes. And blood pressure level, diabetes disease, so the patient has diabetes disease. Artery disease, yes. Appetite, so the patient has a poor level of appetite. And let's say this is abnormal. You can also do some changes for specific gravity. So these are some patient features, medical features. So once you click on this button, then the model will tell that the patient has chronic kidney disease or not. So let's see what the model says. So based on this data, the model must say that the patient has chronic kidney disease, because you can clearly see patient is almost 50 years old, and he has quite a high level of blood pressure, and he has already hypertension, diabetes disease, artery disease. So there is a great chance that the patient will have chronic kidney disease. But let's say if I change, let's say we have a patient with 30 age, and let's say reduce the blood pressure to 40 or 41. He has no diabetes, he has no hypertension, very good appetite, no artery disease, and urine is almost normal. So let's say, so based on this data, the model must say that the patient does not have a chronic kidney disease. So you can see, based on medical features, the model is predicting successfully chronic kidney disease for patient. So let's get started. So always in machine learning, first you need to import all the tools that you will be using for implementing that project. So first thing first, always pandas as PD, then NumPy. So let me quickly import all the tools which are quite basic, because I have already explained these things in my Scikit-Learn for machine learning playlist. Okay. So NumPy pandas, then from model selection you need to import trend test split, because this is the class that is used to help you split or divide your data into test and trace sets. Okay. Then for pre-processing you have to import min-max scaler, or let's say for now just min-max scaler, because we have to scale the data so that the model give equal importance to each value. Now since we are going to train multiple classifiers, so that we can check which one or which model is performing well for CKD disease prediction. So you have a lot of choice in Scikit-Learn, like logistic regression, support vector classifier, random forest classifier, Kmeans, decision tree, Gaussian NB, ADA boost, and gradient boosting classifiers. Now once you train all this classifier, then you need to evaluate like classification report, confusion matrix, and accuracy, so that you can check that which model is performing well based on precision, recall, F1 score, or confusion matrix. Now let's quickly import data set. So pd.read CSV, and you will get this data set in video description. I think the name is kidney disease. So let me call here kidney disease, and if I just show the head of this data, then you'll be able to I think I have to rerun this cell like this, and now let me rerun. So you can see we have this data set where we have a lot of medical results or medical features for patient, like patient age, blood pressure, SG, AL. These are some features. Okay, and this is the target column, which has two values, CKD, which means that, as you can see for this patient, here we have CKD values. It means that patient has CKD. CKD means chronic kidney disease. And there will be another value which is not CKD. Okay, so it's a binary classification problem. But since in this data total we have 26 columns, as you can see, but I'm going to use only 7 or 8 important features like age, blood pressure, some important features with target column classification. So let me quickly filter those columns. Okay. So here we have a list of all those features that we want or we are interested in, like age, blood pressure, and all those input features with the target column. Now if you want to understand all those features, then I have mentioned right here, like age represent patient age in years, blood pressure, SG, urine specific gravity. Now honestly speaking, I don't know about this value, but yeah, this is a medical feature. So as a data scientist and ML engineer, you don't need to know everything, but yes, you just know target and input features. And here HTN, hypertension, which has two values, yes, no. DM means diabetes mellitus, and this is a disease where we have or not for patients. So again, we have two value, yes and no. CAD, coronary artery disease, yes, no. Appetite, the patient has a good appetite or poor appetite. PC, pus cell status, that is, it could be a normal or abnormal. And finally, target column classification, which has two values, CKD, chronic kidney disease, and not CKD. Okay, so once I run this, you'll get this thing. Okay, now this is the data where we have all these input features, and this is a target column. But while encoding, now mainly two steps we have to perform. We have to scale this data, and we have to encode these columns like yes, no into 0, 1, because ML model can only understand numbers. And DM, CAD, appetite, PC, like normal, abnormal into 1, 0, CKD and not CKD into 1, 0. But there is an issue. There is a little bit issue with this data set, whoever created this data. If I go to classification, I mean target column, and show you by calling value counts method, you'll see I think it's yeah, it should be value counts, by the way, value counts. As you can see, it must have only two columns like CKD, not CKD, but whoever created this data set unwillingly or maybe mistakenly, he also typed here \t with CKD. So we need to remove this /t. And if I go to CAD, it has two values, 0, 1, I mean yes and no. But again, whoever created this, again, before no, mistakenly he typed \t. And so again, with this 4 column, we have to remove. So what I can do, I can get these columns by calling df.selectDataType method, and then I can pass include method. Include method will be equal to object, and I am only interested to get all the categorical columns. Okay, so you can clearly see we are successfully getting all those categorical columns. I mean this one, because we are interested only in these columns to be cleaned up. Now I want to run a loop on this categorical column, like for call in this. So if I just print call, you will be able to see that call. Now I will pass the expected call into my data set, and first I want to convert it into string. Then I want to remove spaces. If there is a space, then you can call strip method, then str. Now I want to replace \t with some empty string, and there is a parameter regex. You can keep it true like this. Okay, so this part was extra for us, because as you can see, now we have in CAD column we have only yes, no, again here yes, no, and now only CKD and not CKD. So we are ready. Now the next thing, if I just want to check missing value, because we don't know, but here you can clearly see we have 9 missing value in age column. Blood pressure has 12 missing values, SG has 47. So either you can drop all these missing values, but if you want to drop these missing values, you will lose a lot of information. Because if I just show the shape, total we have 400 patients, and if you also drop the missing values, then you will lose a lot of information. So what we can do, we can fill. So if I just call age wala column, and then I call fill now method. Now what I'm going to do, I just want to calculate the median or mean of this entire age values, and then put that mean or median into that part where we have a missing value. Okay, so I can do that. I can just call age, and I can call either mean, but I think we can go with median.
and in plus will be true. In plus will be true. And I can do the same thing for blood pressure, because we have also missing value in blood pressure. If I just go and call is null method, you will be able to see. As you can see, in blood pressure we have also missing value. So blood pressure like this, and blood pressure. Again, I am going to fill this 12 missing value with the median of the entire column. But as you can see, in these columns we do not have numbers, we have categories. So how to fill that? We can use mode. Like if there is a missing value in HTN, so we have to fill that missing part with most repeated value. So if in this entire column there is a most repeated value is yes, then we can go with yes to be used for that missing part. Like as you can see here, in HTN we have two missing values. So what I can do, I can call HTN, and then I can call fill now method by getting the most repeated value in the existing column. Then you can call mode, and that value will be filled right here if there is a missing value, like we have two missing value. So let me quickly do for all the remaining columns as well. So if I give a quick revise, you can clearly see we have age with median, blood pressure with median, SG with mode, L with mode, MO with median, but here you can also see all the categorical column also filled with mode. So now if I just show, like you can see, now we do not have any missing value in all this column because we successfully filled all the missing value. And this is a good part as a data scientist you have to do. Now the next thing, we have to do encoding. We have to encode all these columns into 0, 1 because ML model can only understand numbers. Now for this, Scikit-Learn provides 3 classes: label encoder, ordinal encoder, and one hot encoder. But what if we do this thing with manually code? Like if I go to HTN and run it, you can see we have this. So we have to convert yes and no into 1 and 0. For now, just let me like this. So HTN, now here you can call map method and you can pass a dictionary, and there you can mention if there is a yes, give it to 1, and if there is no, give it 0, and store it again into HTN column. So in that way you can also encode categorical values into numbers. And if you want for like DM, or if I just show this one PC like this, now in this we have basically two values, good and poor, sorry, normal and abnormal. So I can say map dictionary, if there is normal, normal, give it 1, but if there is abnormal, give it 0. So let me quickly do for other columns. So as you can see, now we successfully converted all the categorical values into numbers. Now the last thing, we have to scale these numerical columns, this one, because sometimes what happens, machine learning model give biased or dominant toward higher values. Like in age, if there is a person with 80 age, then the model will give a higher dominant or higher biased to 80 age in comparison if there is another value which is lower, let's say 7. So it will ignore lower value. So if you want to make the model in a way that it could give equal importance to each value, then you have to bring all the values between the range of 0 and 1. Now for this, Scikit-Learn provide two techniques like standard scalar and min-max scalar. So let me quickly do. So here I extracted all the numerical columns. I'm in this because I'm going to scale only these columns. And then I've created an object of min-max scalar, then scalar.fit transform method, and I have passed all the column and store it accordingly. So now if I just show you, you can clearly see now we have all the values between the range of 0 and 1. Now the last thing before trend split, if I just go and show the target column and by calling value counts, now it has two
classes, one which means CKD and 0 which means not CKD, but total we have 400. So for CKD, I mean for 1 we have 250 patient, and for not CKD, I mean 0, we have only 150 patient. So if you train an ML classifier or ML model on this data, then that model will give higher importance to majority class or higher class. So if you want to again make the model balanced, then you have to balance this data set. Now for this you can use three techniques: random oversampler, random undersampler, and smart. So what we will do, we will generate copies of minority class until it becomes to majority class, so that we can make them equal. So from now this time, either you can use Scikit-Learn resample class, but there you have to do some manual custom code. But here we have another library by the name of IMBlearn. Therefore, from oversampling class, you can import either random oversampler or smart, because both these classes do the same thing. What it will do, it will generate copies of the minority class until it becomes to majority class. But smart has an advantage internally. It's not directly create copies, it calculates some distance and similarity. So yeah, this is the class. Now what you have to do, you have to create an object of this smart class. But first we need to get all the input features and store it into X and the target column into Y. So what you can do like this. So here we dropped target column and all the remaining input features will be stored into X and target column into Y. Then we created an object of smart, and then we call fit resample method and we pass our input feature and Y. Now we have X balanced and Y balanced. So if I just show Y balanced by calling value counts, so this time you can clearly see we have balanced data. Now on this data your model will perform in more better way. Now let's quickly do trend test split, which is quite basic part. So we already have a class by the name of trend test split, as you can see, and we pass our X balanced and Y balanced with test size 0.2. It's mean that from input feature 80% data will be stored in Xtrend and remaining 20 into Xtest. And for target column Y balanced, 80% data will be stored in Ytrend and remaining 20% data will be stored in Ytest. So if I just show the shape, you can clearly see. Right? Now let's train multiple classifier. Since you can train an individual model and can check its performance, but if you want to save your time and space, then you can use you can train at a time multiple classifiers within a single loop. But for that you have to create a dictionary. So as you can see, we have this dictionary by name of models, where we have the model name and the model as it is. So now if I run a loop by getting the name and the model as it is from models dictionary, in model dictionary, basically it's a loop. But if you want to get key and a value from dictionary, then you have to call items method. Now if I print name and the model as it is, as you can clearly see, we are getting the name and the model, But what I want to train model. So first time the loop will get logistic regression, and then I'll call fit method, and by passing my 80% data like this, and then I have to test the model by calling predict method by passing 20% data, and will store the result into ypred or ytrue. Now we have model prediction, so we can calculate confusion matrix and classification report. So let me quickly paste this code right here. So again, we are training the model, we are testing the model, and here I am calculating three things: accuracy score, where I am passing those data that has not been seen by the model, which is Ytest, because this data, this is the data which has no knowledge about this data from the model, and this is the prediction of the model. So we are comparing actual versus predicted. And we are doing the same thing in classification report and confusion matrix. So let's run it. As you can see, logistic regression has given us 96 accuracy, which is quite great. And you can clearly see the classification report of logistic regression for both classes. For not CKD, you can see precision, which is quite higher, recall almost 100, F1 score 96, and you can also see for CKD all the precision, recall, and F1 score, and overall accuracy you can clearly see. So it's mean that logistic regression is performing on this data in a more better way. Now let's check SVM. So 97, again you can see classification report for support vector classifier, and you can see confusion matrix, because in my playlist I have already mentioned you have to focus on diagonal area. If above diagonal and below diagonal you are getting 0, it means your model is not doing a single mistake, but sometime you will get 2 or 3 numbers, like here you can see we are getting 3, so here model done 3 mistakes. And if we focus on other models, let me zoom out. As you can see, random forest 100%, that is a good sign. Now you might be thinking that it could be an overfitting issue. No, because this is on test data, not on training data. And here random forest classifier has not done a single mistake. It's mean that random forest is performing well. Also you can check Canon, you can check decision tree, Gaussian NB, and Adabos classifier, and you can also see gradient boosting classifier. So we can go with gradient boosting classifier. Finally, I'm going to select this model for production or prediction system. So we have to train it separately. So you can see I've created an object and then train it, test it, and you will get the same result. As you can see, 99. Now we need to save 2 things: the train model, which is model gradient boosting classifier, and scalar. Okay, for that you use pickle library. So pickle.dump, pass your scalar. Now why we are saving scalar we will see a bit later, but yeah, you can see we have saved scalar and the model, as you can see. Now if I run this cell and go to my models folder, you will see now I have saved model and scalar, because we are going to use these 2 things for production. So now before going into creating the UI and stimulate app, let me quickly create a function that will get new patient data and will predict the disease. So for that I need to load this to model, and here I have to create a function by any name. Like for now I'm going to create CKD, and this function will do some prediction. See, you need to understand this part. This is very important. We have these 2 model, or you can say scalar and model, and this is the function they are getting for new patient. That patient age, blood pressure, SG value, AL value, HEMO, CS, HTN, yes no, DM yes no, CAD yes no, appetite, good poor, PC normal abnormal. Okay, and then it will use the train model and will predict the disease. Okay, sorry for that. But the first thing, as you can see, I have called this function right here and pass for new patient this data. Now we have to create a data frame of these columns, and then you can clearly see we have to scale this data as we have done before training, and we have to encode this data. Now whatever you have done before training the model, you have to apply the same thing in production or prediction system. Okay, so what I can do, I can paste this code right here. So this is the same function. First I'm going to create a dictionary where I have called pandas data frame method, and I have passed this with the same column names and the new patient data. Then all the categorical columns in the same way I have encoded, like as you can clearly see. Then I have used the train scalar for those columns that are numericals, and we have scaled, and then we have used the train model and have done prediction. Now finally you will have either 0 or 1 for this new patient, and we are returning that 0 or 1 right here, and we are getting right here. and then we are checking if the result is equal to 1. It's mean if the model is predicted 1, then it's mean that for this patient the model is saying that the patient has chronic kidney disease. But if the model has returned 0, then we will see we are saying that the patient has not CKD. I hope you get the idea. This is quite simple. So let me run it. So if I run it, as you can see, the patient has not CKD, because you can clearly see the patient is young, he has very low blood pressure, and almost he has no disease, and he has a good appetite, and he is normal. So you can clearly see the model will definitely say that the patient has not CKD. But what if I pass another patient right here with 65 age, high blood pressure, all diseases, poor appetite, abnormal? So the model must say that yes, a patient has CKD. Now before going and deploying this project into our app using Streamlit library, you need to quickly check your Scikit-Learn version. So in my case, I am using 1.4.2 Scikit-Learn, and if in your case the version is like 1.6.2 or 10 or 1.10.3 or something, then you have to install exact that version in IDE or production. So let's create our app. So you can use any IDE like VS Code or PyCharm. Now the first thing, go to your terminal and create a virtual environment. If you don't know how to create virtual environment, there is a command, you can search about it. So once you create, you will get like this. Then you need to install Scikit-Learn with that version that you have used for training. Like in my case, it was I think 1.4.0. okay. And secondly, install Streamlit. So you need to install these two libraries or tools. Once you install, then you can run this app. Now here you must have app.py file where you will be implementing the backend code, and must have models folder where you have the save model and scalar. Okay. Now quickly import Streamlit, pandas, and pickle. Now you can clearly see with the help of pickle.load method, we have loaded scalar, store it right here, and the save model because we need them. Now let me quickly bring the same function that we have used in Jupyter notebook. Okay. So if I open the Jupyter notebook right here, as you can see, this function, I just need to copy this function because it's important, because this is the main function that is going to return me the prediction, and I'll simply write below this line, I'll paste it. Now you don't need to remember or understand these things, but you must have some knowledge of the flow. So yeah, this is the implementation. Now we need to create user interface. User interface in the sense like title, input fields. So UI. Now here you can call Streamlit library.title, and there you can pass CKD predictor like this. So if I go to my terminal and run it like Streamlit run app.py, so you will see the app will be pop up in your Chrome browser. As you can see, we have this. Now let's quickly implement the logic for input fields. So what I can do, I want to create two call 1, call 2. Then I can call Streamlit library columns method by passing 2. In first column, I mean with call 1, I'm going to get 6 input feature like age, and for that I can call Streamlit library input number input, and there I can pass like enter patient age. Like I can also do the same for blood pressure, and let me quickly do for other columns. So here you can clearly see in column 1 we have age, blood pressure, SGAL, HAMO and CS. So we are getting all the values from user using number input field. Now these are the values that are controlling minimum and maximum values. Now in column 2, I'm going to use this like select box because I want a drop down where we have yes, no for 0, yes, no, good, poor, normal, abnormal. So if I just go and refresh the page, I will be able to see side by side all the input features. It's running, as you can see. Sometimes it takes too much time, I don't know why, but yeah, you can see this is column 1 and this is column 2. Now here we have to add a button. Once user select all these features and click on the button, then we have to display the message accordingly. So here you can say if stimulate library dot button, let's say the button is predictor, then return result by calling predict method. We already have this function, and by passing all this data, okay, like age, blood pressure, SGAL, MO, HTN, DM, CAT, appetite, and PC. And we can check that if result equal to 1, then print. Now here instead of print you have to use write the patient has. So let me quickly do that. So now understand the flow. This is the UI where we are getting all the input data from user. Once we get that data and the user click on this button, we are passing all this data to this function, and this function creating a data frame, then do encoding, scaling, and by the train model prediction. So we'll be getting either 1 or 0 at a time, and here we are checking if the model has returned 1, then the patient has disease, otherwise no disease. So let's try one record. So you can type manually, but I'm going to go with the default just to show you. This is the button. The moment you click, you will get patient has chronic kidney disease. You can try different records and different patient data. For car price prediction. So once you add like the year in which the car was made, how many kilometers that car has been driven, fuel type like petrol, diesel, all those, and transmission like it is manual or automatic, owner type, first, second, third, how many seats in that car has, like 2 seat, 3 seat, 4 seat, and mileage in KMPL, engine type, and power in BHP. So once you add all these features for a car, our model will tell us for that car the price. So as you can see, we have a car with 2020, all this information. Now let's see what the model predict. So the model said that 63.67 lakh could be the price for this car. I have another car, let me quickly change, let's say 2010, and let's say the kilometer could be 300 only, and the type could be, let's say, diesel, okay, and it's manual, let's say third owner, and we have, let's say, 6 seat or maybe 4, and let me change this to, let's say, 10,000 or 100, maybe something. So let's say 60, and the power, let me make it as it is. Now let's click on this button and let's see. So 51.35 lakh. So as you can see, the model is predicting car price by giving all the input features for that car. So it is a regression problem. Now let's get started. So as usual, the first thing you have to quickly import all the tools that you need for this project as pandas, and from Scikit-Learn model selection we need to import trend test split. And so let me quickly import all the tools that I need for this project. So as you can see, we have pandas, and from Scikit-Learn model selection we have trend test split that is used for splitting data set into training and test sets. Then from pre-processing we have standard scaler that is used for scaling. And finally, as we have seen in the previous 2 video about column transformer and pipelines, so from pipeline you have to import pipeline, and from compose you have to import column transformer. Now these 2 classes are used
to combine or reduce your code by merging a lot of pre-processing steps, including model training. Okay. And then for encoding, we have one hot encoder. You can use either label encoder, ordinal encoder, but yeah, I'm going to use this one hot encoder. And this is the model that we are going to use for car price prediction. Now, since this is a regression problem, so instead of classifier, you have to use regressor. Okay. So from ensemble, import random forest regressor. So these are the imports that we are going to use for this project. Now let's quickly import the data set. So you will get this data set in the entire code and implementation in this video description, but yeah, this is the data set. You have to call read CSV, and then you have to pause this used car prices. Okay. And I have explicitly removed these two columns because I don't need it. So now let me quickly show you. As you can see, this is the data. Now again, the first thing you have to ask yourself, is this a supervised learning problem or unsupervised learning problem? So this is a supervised learning problem, but the question is why? Because in supervised learning problem, we have label data that in which you have input features with corresponding target column. So this is the supervised learning problem. Now the second question you might ask yourself, now in supervised learning we have two types, classification and regression. So you have to focus on target column. If in target columns you are seeing continuous values like this, then this is a regression problem. But if you are going to do some classification like two classes, yes, no, 0, 1, then it could be a classification problem. Okay. But currently we are dealing with a regression problem because we are going to predict car prices. Now these are the input features like year, kilometer driven, fuel type of that car, transmission where we have manual and automatic, owner type of the car, mileage, engine, power, and all those things. Now if you see, there are three columns like mileage, engine, and power, in which we have a combination of numbers and strings. Now this is interesting. As a data scientist, you have to figure it out. You have to clean these things. So what we will do, we will get all the numbers and we will remove all the text. We don't need it, as you can see. So this thing could be done with custom code. Like, let me create a function by the name of extract number. It will get a column or entire df, and or let's say it will get some number. Now the first thing, as you can see, we have imported regular expression. So you can do this thing with regular expression by getting all the numbers and removing string. So regular expression dot find all is the function that is used. Now here you have to pass a pattern. This is the pattern that I'll show, like /d/dot. Now you don't need to remember this pattern, but yeah, this is the pattern that is used to get all the numbers from value and skip all the string. Okay, and we are getting this from number. Okay, so let me quickly complete this because it's simple. As you can see, we have this function by the name of extract number that is used to get a number. Like, first we are going to pass this, then this, then this. So what we are going to do, we are going to get only the numbers and we are going to remove or drop this string. Okay, now for that you can do anything, but regular expression is the best tool that is used to get, based on some pattern, remove or get whatever your requirement is. So this is the pattern that is used for this thing, and here we have passed our text, which is this one. Now we have checked if we are getting something like some numbers, then you have to convert it into float and return us. But if we are getting nothing, then just return none. So first what I have done, I have just called this for first column, which is mileage, by calling apply and then passing my function. First I clean this, then this, then this, as you can see. So once you run, and now if I show the data set, now you will see we have clean. We have only numbers. Okay, so yeah. Now the second thing, we have to encode, we have to do two pre-processing steps. First, we have to encode fuel type, transmission, and owner type. Now in fuel type, we have 5 categories like CNG, diesel. We have to convert into number like 0, 1, 2. As encoding we have already seen in previous couple of videos. Okay, and the second could be transmission. where we have manual and automatic, so you can convert them into 0, 1 and owner type accordingly. Now for that we have one hard encoder. Okay, the second thing, these two column like year and kilometer driven are numericals, and also mileage, engine and power and seats are numerical. So as you can see, we have different values. We have smaller value and larger value. So we have to bring these values between the range of 0 and 1, which is known as scaling in machine learning. So we have to do scaling, either you can use min-max scaler or standard scaler. But since I am going to combine all these steps by using pipeline, as so what you can do before that, let me quickly show you df null value, missing value. So as you can see, we have some missing values, so let's drop them. We don't need to fill them, but you can fill with the class of simple imputer. So drop NA, where in place will be true. Okay, if I show now the shape, you will get some 5,000 or 6,000 car records. Okay, so now finally we have this data. Now after that we have done trend test bed, which we have already seen in this playlist, which is quite simple. Now for training and splitting, you have to use trend test split by passing your all input features and corresponding target. So now we have 4 sets: xtrain, xtest, ytrain and ytest. Xtrain and ytrain are used for 80% data, where we will be training the model with this 80% data, and xtest and ytest will be the 20% data that we will be using for testing the model. Now let's create a quickly pipeline where we will pass 3 things. So the first, as you can see in this data, if I just show head, as you can see we have scaling step, these are the columns that we are going to scale, and encoding step, and finally model training step. So we have 3 steps to be used for pipeline. So let me quickly get all these columns. As you can see, I have a variable by the name of categorical features, where I have fuel type, transmission and owner type, because these are the 3 columns that I am going to encode. And I have all the numerical columns in numerical features, where we have year, kilometer driven, seats, mileage, engine and power, right? Now after that we have created object for one hard encoder. You can give it any name, and standard scaler. Now we will apply this for scaling, for encoding this 3 column. Basically we are going to apply this on this variable, and standard scalar we will be going to apply on scaling columns or numerical columns. Okay, now let's create a column transformer processor. So as I already mentioned in previous video, you have to call column transformer. Now in this column transformer you have to pass transformer. Okay, now this transformer could be a list where you have tuple. The first tuple could be for first pre-processing step, where let's say encode, I'm going to encode using this categorical, categorical, let me call it, let me quickly finish it. So as you can see, we have this preprocessor where we have 2 steps: first numerical transformer, second categorical transformer. So for each tuple you have to pass 3 things. First, name, it could be anything. Second, your transformer, which is numerical transformer, and third, the column that are going to be applied for this pre-processing step, which is numerical transformer. So we are going to apply this numerical transformer on these numerical features, and the same thing we have done for categorical transformer. Now finally we have this preprocessor. Now let's create another preprocessor or pipeline by combining this preprocessor and the model. So now finally you can see we have this pipeline where you have to pass steps. So in first tuple we have passed the preprocessor, which is this one actually, and in second step we have passed our random forest regressor model that we are going to train on for this data. After that we have called this model pipeline and fit, then xtrain and ytrain. Now as you can see, in couple lines of code we are doing everything at one place. So let me run it. As you can see, it's in running. As you can see, xtrain, I think I forgot to run this cell. Yeah, so let me rerun. So as you can see, now we have this column pipeline where we have column transformer with numerical and categorical like scaling and encoding, and finally pipeline with model, that is random forest regressor. Now you have only this thing, you can use only this one variable for production or testing or integration. Okay, so before saving and integrating with the web app, we need to test this model. Now since this is a regression problem, so for regression problem what you have to do, you have to import from scikit-learn.matrices, you have to import R2 score, mean squared error and mean root error, but for that we can use numpy. So import numpy as np. So since this is a regression problem, and for regression model evaluation you can use R2 score for model performance or checking model accuracy, and if you want to check model error then you can use mean squared error. So as you can see, we have called model pipeline and we have passed our test data. Now all the prediction will be stored right here. After that we have calculated R2 score by passing y test, which is the 20% data that has been not seen by the model yet, and all the prediction done by the model for X test. Now we are going to compare this model prediction, I mean actual data, and model predicted data, and then we have done for mean squared error and also for mean root mean squared error. So for root mean squared error you can use np.square root and pass your this. Okay, so let's see. As you can see, the model is giving us 90% score, which is great, which is totally amazing for regression problem. And you can see mean squared error is 10 point something, which is okay, we can go with that. And root mean squared error is also good, as you can see. So if you are getting more score, it means your model is performing well. If you are getting less error, it means your model is also doing great job. Now let's create a prediction system before jumping into creating the website, so that we can see the model. So what I can do, I can create a function def. So the process is quite simple. We have a custom function by the name of predict car price, where we are passing our train model and all the new input feature for the new car, for which we are going to predict the price, like that car year, kilometer driven, fuel type, transmission, owner, seats, mileage. As you can see, we have this new car where we have a car that is made in 2010, kilometer driven this, fuel type, transmission, this is a new car data, and we have passed this data to this function, which is actually this one. Okay, predict car price. Okay, so we have passed all the new car data. Now the first thing you have to do within this function, you have to create a data frame of this new data. Okay, so just call data frame method by creating column name and that value, column name and that value. Now finally we have this data for the new car input, and after that we don't need to do some pre-processing or retraining the model. You have to just call this model pipeline, because internally it will handle everything like encoding, scaling and everything, and also prediction. And finally it's returning us the car price that we are getting right here, and after that we are printing that price right here. So let's see for that car. As you can see, for this car the model is predicting 1.90 lakh. Okay, so it's good, it's good. Now let's save. Now for saving, what we need to save, we only need to save model pipeline. So you can use pickle library like pickle.dump, then pass your model or model pipeline, and then save it with this extension and name. Now once you run this, you will get the model right here, pipeline.pkl, because we have given the name pipeline.pkl. So now we are ready to create UI and integrate this pipeline in our backend. So let's do that. So I have opened IDE PyCharm. You can use VS Code or any IDE which is good for you. But since today in this project we are going to use Flask framework for creating the website. In previous 2 or 3 projects we have used Streamlit library, which is simple as a data scientist. But creating a proper real word website, you need some knowledge of basic web development like HTML, CSS, and also Flask framework that is used for backend. But if you don't know, if you are totally beginner, it's okay. Now this is the basic syntax. Okay, the first thing you have to create templates, because Flask need templates for creating HTML files. So you have to create exactly with the same spelling, same name, templates. Now within this templates you have to right click on template, new, and then you have to create HTML file by the name of index.html, as you can see. So once you create, you will get this. By the way, I'm going to share all this code with you, but yeah, this is the basic syntax where we have also integrated the basic CSS. So if I just quickly show you how it looks like, you'll better understand. Okay, now within the body, this is the body where you can create your page. I'm going to add h1. This is my first web app. So if for now I directly run and open this app in my Chrome browser, you will get something. It's loading. You can see this is my first web. Now this blue color is because of the CSS, because I have applied this color. As you can see in the body, this is CSS. If you don't know, you don't need to remember all these things, but just follow the process. Okay, but yeah, I just wanted to show you that your website might looks like this. Now the main thing, app.py file or man.py file, where you will be using Flask. Now first thing first, go to your terminal and install two things. Pip install Flask Scikit-Learn. You need to install these two libraries or frameworks. Now let me quickly import from Flask. Import capital F Flask. This is the class. With the help, you can create the app and a render template. Render template is a class that is used for communicating between front end and back end. I mean index.html file, which is actually your user interface, and app.py, which is the backend. Okay, and request. You will understand these things. Second, we need pandas as PD, and also we need pickle. Okay, import pickle. Now let's create app. So how to create app? You have to create like this by calling capital F Flask, where you have to pass this parameter. Now you might be thinking, what is going on? This is built-in syntax. We are not allowed to change it, but yes, this is the basic syntax. Now once you done this, then you have to call Python man, and in Python man you have to write name that is equal to man. Okay, and then you have to run the app, and debugger must be true. So now you can see this is the backend code. Now if you want to run your front end directly from backend, previously we have run like we ran from here. Okay, but if you want to run your execute your app directly from here, then you have to create routes so that they could keep communication between front end and back end. So how to create route? You have to create route like this. Okay, so default, there you have to give some time path, but for now I want default one. This is the route, and then I'm going to create a function by the name of index, and once I run this app, this function will be triggered, and once it triggered, then I want to return toward, with the help of a render template, toward index.html. Now let me remove this thing. Yeah, so now if I run, you will get your URL right here. Then you can click on that URL. As you can see, if I click on this URL, now my app will be properly running from my server. Okay, on this port. This is the port on which this simple app is running. So it's loading, I don't know why. Yeah, as you can see, so now your app is properly running on this server. Perfect. Now the first thing we have to work on creating the user interface. Okay, so first let me quickly, okay, the second thing that I just wanted to show you, I'm also using Bootstrap library that is basically providing you some built-in classes for the design and CSS. Okay, but yeah, let's create the UI. Now for that you need HTML tags and containers. So this is my first container in which I am going to use h1. Like here I can use add class like text center, and there I can write car price predictor. So if I just refresh it, as you can see, car price predictor. Now after that I'm going to add form where we will be getting all the input fields for the car, like car year, kilometer driven. For that you use form. Now you can remove action, but yes, you can pass method post. And now within this form you have to pass some bootstrap classes like row, and in the first row I'm going to add 2 fields. So for that you can use another call md3 like this, and within this I am going to use label. So first will be year, and then input field. So then you can use input. So type will be number, and you can pass name like year. And let me just quickly show you that how it looks like. As you can see, we have this first field. Now I want here another field. So I just want to copy this, Control C and Control V. As you can see, now we have 2. Now in the second row I want another 2 fields, and in the third row I want another 2 fields. So what we can do, so if I just quickly show you, then explain you, then you will understand. As you can see, now we have this proper design container where we have all the input fields. This is the first row where we have 2 input fields. Second row we drop down. Okay. Now you might be thinking what happened. So we have this container where we have a bootstrap class by the name of card p4. These are some built-in classes that provide built-in CSS. Then we have this h1, okay, car price predictor. Now this is the form, this is the entire form, okay, in which we have, this is the first row where we have 2 input field, year and kilometer driven. This is the second row where we have 2 drop downs. Now for drop down you don't need to use input field, you have to use select, okay, and here you have to mention all those things. Now these are basic things, you just need to get this code and try it manually so that you can understand what is going on. But yeah, here you can see before the form we have also added submit button, okay, predict price. So if I just refresh, as you can see, we have this form with a drop down. Now again, let me repeat, I have just used copy paste because these things are very simple, and as a data scientist you don't need to remember all these stuffs. But sometime you might be working with web development, so at least you must have some idea how to create form, how to create input fields, drop down, okay. Now these are the names. For each input field we have name, okay, for each input field we have name, as you can see. So in backend, let's say when user type fill all this input field and click on the submit button, so in app.py we have to get all these values, okay. So as we already created this root with the function index, but here you can see I have passed methods either get or post, because in front end in form we have method post. So as a web developer, if you are a web developer in some basic knowledge about web development, you might have heard or seen there are 2 methods, post and get, that are mostly used between client and server. This front end is also known as client side, okay, and app.py is also known as server side. So if you pass data from client to server or from server to client, then you will have use this get and post. Here we are creating empty folder, variable, and then we are checking if request.method, request is basically we have already imported, that is used to do request to front end form, okay. And then we are going to call, first we are going to see if the request is post. If this is post, then get all the values like from year, from kilometer driven, fuel type, transmission, and get and store in this variable. then we are passing this variable to the same function that we have used in predict car price. So what I can do, I can paste that same function right here. This is the same function that are getting all the input fields including the model, then creating the data frame, and then the model is predicting and returning us the price, and we are getting that price right here. And once we get this price, then we are passing this price toward index.html with this like predicted price will be equal to predicted price. For now, if you don't know what is going on, no worries. But finally, once we get all the data from input field and do all the prediction, then we are returning the predicted price for the car that is stored in this variable. Now we only need to print that variable after form. Okay. For that you have to use Python code within HTML, and this is known as Jinja template like this. So first I'm going to check if this predicted that we are getting from here, if it is not none, let me copy, is not none or empty. First let me quickly close this. If this is built-in syntax that helps you. This is the beauty of Python basically. Yes, Python provides the ability to code Python code or programmatical code in HTML. Now here you can print using paragraph tag and print that price. So how to print? You can use double open square brackets, curly braces, and close curly braces. Okay, so here we have to pass this predicted price, but I'm going to make it more attractive, so I can use bootstrap classes. So here you can see we have this div with some bootstrap classes and then message, and we are printing this with round up to. So finally whatever we are getting right here, we are displaying to the user that predicted price right here. So what will happen? What will happen if I just refresh? As you can see, this is form, this is user interface UI, and this is the entire form where you will add all the values. And once you add all the values, let me type some random values like this. And once you click on this button, this all data will be got it right here, all the data, and that data we have passed to the function, which is this one, this function where we are using the model, and this function is returning us predicted price, and we are getting the predicted price right here. And again we are passing this predicted price to index.html where we are displaying right here. So let's try it out. So the moment you click on this button, you will get this predicted price. Okay, let's try some more data like the previous one. Let's say 2005, some this kilometer driven, LPG, let's say automatic, and we have only 2 seat. It could be, let me also reduce this to 3000. It could be like mileage, let's say 45, or this, and power, let's say this. So if you click on this button, we are getting 0.98 lakh. Okay, so for this score, the model is predicting this price. Recommendation system project using machine learning. So here you can see we have this input features data. Here you have to pass nitrogen value, temperature value, phosphorus, humidity, potassium, rainfall, and soil pH value. So it's mean that you have to add some chemical and environmental or related soil related based input features, and once you click on this button, the model will recommend that crop that is suitable to be cultivated right there. Okay, now let's say I have a value for nitrogen 50, and let me increase the temperature to somehow 40, let's say or 35, or let's say 25 for cold weather. Okay, and let me reduce humidity to 20, and let me make other values as it is. So now let's see. As you can see, the data is mostly related to cold weather. somehow cold weather. So let's see what the model recommend. So kidney beans is the recommended crop for this type of environment or features. Now let me increase, or let me make something like hot weather. So let's say 120, or let's say 80, or maybe 60 is the temperature. Humidity is 120. Rainfall is 220. And let me also increase soil to 14 pH value, and you can also make this value to somehow 90. Now let's see what the model recommend for this. As you can see, papaya. So papaya is the most recommended crop for such environment. And let's say if we increase the temperature more, or let's say 50, and let me increase nitrogen to 120. Let me also increase this to 120. Potassium, let's say 140 or 50. And let's say this 11. Let me also increase humidity to 170 or 80, and rainfall 120. And let me make it 51. Okay. So once you click on this button, as you can see, apple. So apple is the recommended crop for this type of environment or weather condition. So as you can see, the system is working. So first of all, we need to import a couple of tools like pandas as PD. Then we need to import numpy as np. Now let's import sklearn tools, like from sklearn dot preprocessing. Preprocessing, you need to import minimax scaler. Now minimax scaler is a class that is used for scaling data, and we also need level encoder. Now from sklearn dot model selection, you need to import trend test split, that is used for splitting or dividing data set into trend and test sets. Okay. Now let me import 3ml classifier that we will be using for this data to be trained and evaluated. Okay. So 3 classifiers. Now we have a lot of classifiers in machine learning, but we will be using from sklearn dot linear model, we will be using logistic regression, and from sklearn dot ensemble, you need to import a random forest classifier and gradient boosting classifier. So we'll be using these 3 classifiers for training. Now once we train this model, we need to evaluate. So for that we need, like from sklearn dot matrices, we need to import classification report and confusion matrix. So these are the tools that are used for building ML project. Okay. Now let's quickly load crop dataset. So df, then pd.read csv. Now there you have to pass the name of the dataset. So if I show the dataset, I think I have to run this cell. Yeah. Now let me run this. So as you can see, this is the data set. So these are all the input features, and this is the target column. So this is a supervised learning problem, because in supervised learning problem we have a label data set where you will have input features with corresponding target column. Now if you focus on target column, as you can see, we have couple of crop names. So we are going to classify these names. So it's multi-classification problem. Okay. Now there are a lot of input features like N, P, K, temperature, humidity, pH value, and rainfall. Now these are some environmental and chemical and soil related features for that specific crop. Okay. Now the first thing, let me quickly encode this target column. So if I show you label and call value count, as you can see, we have total, if I just call length, then you will be able to see how many classes we have. So total we have 22 classes. So it's a multi-class classification problem. Okay. Now as you can see, we have rice, we have maize, chickpea, kidney beans, and this crop, banana, mango, grapes. So we have different crops. Okay. So now based on these values, our model will recommend a more similar or top related or predicted crop for that soil. Okay. So we need to encode this. For that, what you have to do, you have to create an object of label encoder and then call the class that is label and call encoder and call fit transform method. So there you have to pass again label. So now if I show the data set, you will be able to see now we have successfully converted all classes or categories into numbers from 0 to 21. So total 22 classes. Now, as you can see, all the input features are numerical, and if you want to train a model on such data where you have smaller and larger values, then the model will give importance to larger values. It will skip lower values. So this is not a good way to train a model. You need to properly bring all these values between the range and 0 and 1. That is known as scaling in machine learning. So Scikit-Learn provide two types of scaling techniques, min-max scalar and standard scalar. Okay, so create object and then call all the columns. So call scalar, then fit transform and pass those columns that you want to transform. So we have all the input features. So let me quickly create a list of all these features. So let me quickly paste right here. As you can see, we have a list of all the numerical features, like all these chemical or environmental features that we are going to scale between the range of 0 and 1. Then we have created an object, then we have called fit transform and pass all the numerical columns, and then we have store accordingly. Now you will be able to see the data in a different format. Now all the values are between the range of 0 and 1. So if you train a machine learning classifier or model on this data, then that model will give equal importance to each value. So now we are ready. We have to split this data into training and testing sets. So what you can do, first we need to get all the input features. So df dot drop target column, which is basically label on axis 1, which represent column wise. And so all the remaining input feature will be stored in X. And now let's store target column into label. Okay, now let's create 4 set train, X test, Y train and Y test, and then call train test split function that we have already imported from Scikit-Learn model selection and pass input features data and target. And here you have to specify test size, which will be 0.2. It's mean that from input features, 80% data will be stored in X-train variable, and from input feature, 20% data will be stored in X test. And the same thing goes with Y. It's mean that from target column label, 80% data will store in Y train and remaining 20 in Y test. So let's run it. So now we are ready. What we have to do, we have to train the 3 classifiers. So I will create a dictionary where I will have logistic regression, and there I'll have call this model. Then I have random forest classifier, and then I will call random forest classifier, and then I will call gradient boosting classifier, and then I'll pass gradient boosting classifier. Now I will run a loop because I want to save my time. So for that loop will get the name and the model as it is from models dictionary. So if I just print name and model, then you'll be able to see, as you can see, it is the name of that model and this is the model as it is. Now what will happen, the first time when the loop will be running, it will get logistic regression, and then I will train it by passing 80% data from train set and 80% data from corresponding target column. Once it ran, then I will test this model by calling model.predict method and pass 20% data, and whatever this model will predict will be stored in ypred. Now I will calculate comparison by printing confusion matrix like this. So here I have to call confusion matrix that we have already imported from matrices. There I have to pass those data that's not been seen by the model yet and the data that has been predicted by the model. So we are going to compare model prediction with our actual data, and I'll do the same thing for classification report. So let me quickly give it a name like report, and here just change it to classification report. So let me run it and let's see. As you can see, this is the confusion matrix. Okay, one thing, let me also print model name. So name, and then I can call name because we are also getting the name. So let me run it. Now as you can see, for logistic regression, this is the confusion matrix 22 by 22 because we have two classes. Okay, so here you can see logistic regression performing very well, but if I show you its classification report, so logistic regression giving us 94 accuracy, which is a good sign, and it's mean that logistic regression performing very well. And you can also see for each class logistic regression precision, recall, F1 score. Okay, so almost 99 and 100, which is quite good performance. And you can see confusion matrix. So I have already mentioned in my Scikit-Learn for machine learning playlist that before diagonal if you are getting more zeros, and below diagonal if you are getting more zeros, it's mean that your model is not doing a single mistake. So here logistic regression is performing very well, but in some cases you can see it's also doing some mistakes. Okay, you can see, but overall it's performing well. Now if we see random forest classifier almost doing nothing. So it means that it's performing very well in comparison to logistic regression, and it's giving us 99 accuracy. So there is an issue with gradient boosting. Let me check. So gradient boosting report, you can also see gradient boosting confusion matrix, but as you can see gradient boosting is giving 99, and sorry, this is the classification confusion matrix for gradient boosting. So you can go with random forest or gradient boosting for production. So let's go with gradient boosting. So I am going to separately train this gradient boosting classifier in the same way because I am going to save it for production. So let me run it, and it's training and predicting and calculating confusion matrix and classification report. So as you can see, we have this results for gradient boosting. Now we need to save three things before going and creating user interface and deployment. Okay, we need to save encoder, model, and scalar. So for that you have to use pickle. So pickle.dump, pass your encoder, and I'm going to save encoder with this name. Okay, and then I have saved model and scalar in the same way. So if I run this cell and go to my models folder, you will be able to see that we have successfully saved encoder, model, and scalar. Now we can use these save models anytime in future or with any user interface or website. Okay, now before creating user interface using Streamlit, let me quickly test these three models or files for new crop data. But first I have to load this save file. So what you can do, pickle.load, then pass encoder, scalar, and model. So you have to just load them. Now let me create a function by the name of predict crop. So it will get new data like all the values or features that we have used. Okay, so let me quickly pass all the features. So here this function will get all the values as a parameter. Now within this function, first
let me quickly pass it. Now I am going to call this function. So predict crop, and I'm going to pass couple of values. So I am going to copy these values. Okay, these are my new input data. So as you can see, this 90 represent N value, 40 represent P value, 40 represent K, we have 25 temperature, humidity is 80%, pH value 6.5, and rainfall 100. Now the first thing, we have to convert all these variables into a data frame using pandas data frame function. So here you can call pandas data frame, and there you can pass data and columns name. So let me quickly pass like this. As you can see, we have data frame where we have passed all the input features that we are getting right here and creating the columns accordingly. Now before prediction, we need to scale these features, okay, because we already scaled before training model, so you have to also repeat that thing as well, and then we will be using this train model for prediction. So as you can see, we have this new data, environmental and soil related chemical features, and we are getting all this data right here. Then we are creating a data frame, then we are calling scalar transform method, and by passing this input df. So once we scale this data, then we are passing this data to model and predicting. So the model will predict any class, either 0, 1, 2 until 22. Now here we are calling encoder inverse transform method, so that we get the name instead of number, and then the name will be right here, and we are returning the name right here, and we are getting here, and we are printing right here. So if I run, you will be able to see for this data the model predicted or recommended the crop jute. Okay, so now I have couple of test data, different environmental and chemical features, and here I am passing one by one record to the above function and printing its prediction. So let's see what the model say. So for this data, the model is predicting jute. For this data, the model is predicting maize crop, and for this data, the model is recommending jute, cotton, jute, maize, and here for this record, the model is recommending banana. So here you can see the model is performing well, and it is doing prediction accordingly. Now let's quickly create user interface using Streamlit library. Now the first thing, you need to open any IDE like VS Code or PyCharm, and there you must have this models folder where you must have all the three files like encoder, model, and scalar that we have saved with the help of pickle library. Okay, then you have to create app.py file where we will be implementing UI and backend code. Okay, as you can see, I have already app.py. So the first thing, we have to import Streamlit, and we have to load all the three save files in the same way. Okay, so here you can see I have imported Streamlit library as st that helps you create UI, and pandas and pickle. Now with the help of pickle load method, I have successfully loaded encoder, scalar, and model, and accordingly save into encoder, scalar, and model. Now let's quickly create user interface. But before that, if you have no idea how to use any IDE like VS Code or PyCharm, then I recommend you that once you open this entire folder in VS Code or PyCharm, then go to terminal and create virtual environment. Once you create virtual environment, you will get this thing. If this is available, then you can proceed and install like pip install Streamlit library and Scikit-Learn equal to 1.4.2 because we have used this version during training. So once you enter, it will install Streamlit and Scikit-Learn library accordingly. Now let's quickly implement UI. So UI code here. Okay. So the first thing that I want, like Streamlit title, and there I can give like crop recommendation system like this.
Now if I run it, you will be able to see. Just let me quickly run this app so that we can see the UI. So in your terminal you have to call stream like streamlit run app.py and enter. The moment you enter, your app will be pop up in your Chrome browser or any browser you are using. So you will see the title that we have given with the help of st.title. So as you can see, it's running. So here we go, you can see crop recommendation system. Okay, now the next thing, we are going to get all the inputs in real time from user whoever using this app. So you can do in different ways, but I mostly like to create columns. So here you can use streamlit columns function, and there you can pass number of columns. So I want to create 2 columns because I want side by side input from user. So let me quickly first call 1, and there first I will get value for n. So if you want to get a value from user, then you can call streamlit dot number input, and there you can say enter n value or something related. Then let me also get value for p, st dot number, like this, enter p value, and now let me copy call 1 and let me test it right here. So let me change it to call 2. So I just want to show you that how call 1 and call 2 looks like. So if I just go to my page and refresh it, you will be able to see a different look. Side by side you will be seeing input fields. So it's running. Okay, there is an error because just let me quickly change something dummy for now, these variables. Now let me refresh. So as you can see, we have side by side 2 inputs. Okay, now let me quickly enter all the actual values and variables. So what I can do, I can simply replace this code with this one. So this is a similar code. Now here you can see we have npkph value with call 1, temperature, humidity and rainfall with call 2. So if I just go and refresh, you will be able to see all input features. So yeah, you can see. Now here we have to add a button by the name of recommend. Once user input all this data and click on that recommend button, then we will be displaying the recommended crop. Okay, so what you can do, you can simply call if streamlit library dot button, and there you can pass any name like recommend. So on click of this button, we are going to call crop predict function, and we will pass all the value like n, p, k, ph, temperature, humidity and rainfall. Okay, and this function will return a result, recommended crop, and we will be printing that result using streamlit write method. Okay, like you can say recommended crop, and then you can print this result. Okay, now we need to bring this function. This will be the same function that we have already used in Jupyter Notebook. So now let me quickly explain. First of all, we have imported like streamlit, pandas and pickle. Then we have loaded all the trend model that we have saved like encoder, scalar and model. This is the same function that we have used at the end of Jupyter Notebook. This function gets all the new data for a specific crop from user, then creating data frame, then scaling, predicting by the model and getting the name using encoder, and it will return the name or recommended crop. Here we are creating the title and columns. In first call we are getting couple of inputs, in second call we are also getting inputs, and once we get the data from predict crop method, we are getting that crop name right here, and then accordingly we are displaying. Okay, so now let me quickly show you the output of this model. So let's say I am going to add some higher value like summer related temperature value. Okay, let's say make it 120 and temperature let's say 60. It's mean that whatever the area or soil is there, we have a lot of temperature. It's mean related summer, okay, or hot weather. And phosphorus let's say 70, humidity let's say 90, rainfall let's say 120, and you can change potassium like 98 or something, and soil type let's say 11. Now the moment you click on this recommend button, you will get, so as you already know that banana is a type of crop that is mostly cultivated during hot weathers. So the model is predicting correctly. Let me add some cold area or cold weather data. So let's say 50 or 40, temperature let's say 20. It's mean that we have a cold temperature or area. Phosphorus let's say 40, let's say 43, potassium, soil type let's say 3 point something, and let me change humidity. If we have cold, then we have to reduce humidity to 30 point something, and rainfall let's say in cold weather rainfall could be reduced to 54 let's say. So let's see what the model is saying. Moth beans. Now I don't know about this crop, but yeah, this crop is mostly I think cultivated during cold weather. Okay, so yeah, you can see the system is working.
So again, we are going to implement an end-to-end machine learning project for regression problem, that is crop yield prediction. Now by giving the area or the country that is used to produce crop, as you can see we have Albania. You can pass another country like USA, India or Pakistan. Then the type of the crop like wheat, maize, corn, and the year that you want, that how much crop will be produced in that year. It could be in past or in future. And average rainfall in that area in millimeter per year, okay, and pesticides in tons, and finally average temperature. And once you click on this button, you will get the predicted crop for that area. So let me change, let's say India. Now as you know, India is a large area and it's a big country that produce I think almost 80% of agriculture. So let's see wheat, and let's say 2026, let's say 2025, and let me increase the average rainfall to somehow 25, and pesticide we need to increase because India has a large agriculture facility, so we can increase to somehow like let's say 1200 or maybe 2000. And average temperature in India I think 44 or 43 or maybe 41. Let's see. So as you can see, we are going to predict crop yield for India by passing crop which is wheat year 2025 and all these features. So once you click on this button, now in 2025 the predicted crop yield for India is as you can see 25,015.32. So the model is predicting correct continuous value or crop yield for any type of area as you have used in the data set. So again, this is an end-to-end machine learning project where we will be using Scikit-Learn and Streamlit library for creating this user interface. So if you are new for this channel, then I recommend to subscribe this channel and also like this video. Okay, so now let's start implementation. Since in the same playlist Scikit-Learn for machine learning, we have seen all the basic classes and function of Scikit-Learn, like all the imports or the model imports and trend template. Then we have seen how you can encode categorical data into numbers, or how you can scale numerical data between the range of 0 and 1. So we have seen a lot of things in this playlist that are mostly used sorry for that, in machine learning project. But just I want to show you how you can implement a regression problem, as we have seen in the previous video, for car price prediction. So things going to be repeated. As you can see, we have imported pandas, because with the help of pandas you always load your data set. Now again we are going to use pipeline so that we could reduce our code and combine multiple pre-processing steps. So you have to import from pipeline, and from pre-processing you have to import standard scaler and one hot encoder, because standard scaler is used to scale your data set, and one hot encoder is used to convert categorical data into numbers. Okay, now pipeline also need another class that is known as column transformer. So from compose you need to import column transformer, that is actually used to combine multiple pre-processing steps like scaling, encoding, and for dividing our data set into train and test sets we imported train test split. And now again you can import a lot of model like linear regression for regression problem, support vector regressor, but since I'm going to use a random forest regressor. Okay, now if you want to evaluate or check the matrices for regression type model, then you need to import from matrices R2 score, mean squared error. So these are all the basic things that we have seen in previous video already. Now this is the data set that we are going to use in this project. Let me quickly run it. As you can see, this is the data. Again, this is a supervised learning problem. The first thing we need to understand this data set properly. Now in supervised learning problem we have two types, regression and classification. So you need to focus on target column. This is our target column. This is basically the yield for that graph for that area or country. Okay, so by giving the area, the item or the crop, the year, average rainfall in that area, pesticides those pesticides that are created in that area, and average temperature. By passing or giving all these input feature, the model will predict yield. Okay, so yeah, this is the data set. Now first we have to encode these two columns, because these are string or text, or you can say categories. We have to convert them into numbers, because ML model can only understand numbers. The second thing, we need to bring all these numerical values between the range of 0 and 1 except the target column. Okay, so we already discussed all these things. Now the first thing, let's quickly do trend test split. So if you have watched this playlist, or if you have accessed all the previous videos, then you might be familiar with trend test split. So basically you are passing all the input features and corresponding target column and getting these 4 variables. Okay, now let's create a pipeline. So since we are going to implement three steps in the sense, first we are going to do scaling on these features, secondly we are going to encode these two columns, and thirdly we are going to train random forest regressor. Now I need to explicitly get all these columns. So I have a list of all the categorical columns that are area and item, and I have stored in categorical columns. Okay, and I have explicitly extracted all the numerical columns like year, average rainfall, pesticides in tons, and average temperature. Right now, since we are going to implement standard scaler on all these features and one hot encoder on all these two categorical features, so we need to create objects. So for standard scaler we have this object with the name of numerical transformer, and for one hot encoder we have this object that is categorical transformer. Now I am going to combine these two steps. For that we need to use column transformer. Now in column transformer, basically you call column transformer and then you pass this parameter which is built in. Now this is a list. Now in this list you have to pass all the pre-processing steps that you are going to combine. So the first step is to scale all the numerical columns between the range of 0 and 1. So here you have to pass a tuple where you have three things. First, the name, it could be any type of name. Secondly, that preprocessor or that preprocessing step, that is standard scaler. As you can see, this is the object of standard scaler. And third, from your data set, all those columns for which you are going to apply this column transformer. So we have all these numerical columns, which are actually this one. The second preprocessor step that we are going to combine by using column transformer is this, where we have passed categorical transformer object, and these are the columns which are actually area and item. Now finally we have this preprocessor. Now we need to merge or combine this preprocessor with random forest regressor using pipeline. So what you have to do, you have to just call pipeline class, where again you have a built-in parameter or function, that is steps. Again you have to pass a list, and within this list you have to pass tuple. So the first tuple is preprocessor, which has 2 steps, and our random forest regressor. So finally we have this single pipeline which has everything, data pre-processing and model building. Then we have run this pipeline by calling fit and by passing our 80% data with xtran and ytran. So once you run this, you will get right here a pipeline. So as you can see, we have this pipeline where we have column transformer. In column transformer we have numerical pre-processing step and categorical or encoding pre-processing step, and finally we have combined preprocessor with random forest regressor. If you expand, you will get, as you can see, if you expand, you will get like this. Okay. Now let's evaluate this model. So since this is a regression problem, so first you need to call pipeline, then predict on x test data. So all the predictions are right here. Now we have called R2 score, where we have passed y test, which is the actual data, and y pred, which is the predicted data, because we are going to compare actual versus predicted data, R2 score, and then we have calculated mean squared error. So if you want to also print root mean squared error, then you can use numpy. But for that you can, or let me just quickly print this so that we can see. As you can see, the model has achieved 98 accuracy, which is great and good one. But as you can see, the model has a quite big error in the sense of mean squared error. So if you want to also check root mean squared error, then mean squared error, let me copy it, then let me import numpy as np, then I can say print np dot, there is a method by the name of square root. It should suggest me, I don't know why it's not suggesting me, but yeah, square root, and then you have to pass mean squared error. Okay, this should be mean squared error. So yeah, but in the sense of mean squared error, as you can see, the model is giving low error in comparison to mean squared error. So yeah, as you can see. Now before creating the user interface, let me quickly give you an example of this model for new area or prediction. So what you can do, you can create a function by the name of any name, like let's say, first you need to understand we have this new input data where we have area Albania, where we want to check wheat, year is 2025, and these are the all other values. Now I'm going to create a function by the name of predict crop yield, where we will be getting the train model or pipeline, and then the area, item, year, average rainfall per millimeter per year, and finally pesticides in tons, and average temperature. Okay, so we are getting this new input data. The first thing, we need to create a data frame of all these new input data. Then we will only use this pipeline for prediction. So as you can see, this is the complete prediction system function. As you can see, predict crop yield, where we are getting pipeline and all the new input features. Okay, first here I am using pandas data frame method, where I am going to create these columns, basically a data frame with corresponding new input data. Okay, and finally we have this input data. Then we have just called pipeline, and then predict by passing this input data. Now internally pipeline will do encoding, scaling and prediction. Okay, and finally we are getting this is the predicted crop. So here we have called the function and pass all these variables as an argument, and the function is returning us predicted yield, and we are getting right here, and finally we are printing right here. So if I just run, as you can see, the predicted crop yield is this. Now we need to save this pipeline because this is the main thing that we are going to integrate or deploy with our Streamlit app. So you just need to call this. And now for saving or converting your files into a PKL file, then you need pickle library, pickle.dump, then pause your pipeline and save with this extension. We have seen these things in previous video. Now let's create the user interface. So let me repeat, you can use any IDE as I have mentioned in previous video, either VS Code or PyCharm. But the first thing, you need to go to your terminal, and there you need to install, create a virtual environment, and then you need to install with the help of pip Streamlit library and Scikit-Learn. Okay, so once you run, it will be installed automatically. Now here you must have app.py file. You can right click on your external folder, go to new and Python file. You can create by the name of app.py or main.py, whatever you want. Okay, and you must have the save pipeline.pkl file. Perfect. Now let me quickly import Streamlit library as st. I also need to import pandas as pd. I also need to import pickle. Okay, now let me quickly create custom Python function where we will be going to implement the UI logic. Let me zoom out a bit. Yeah, so it could be a function by the name of man. Now within this let me just make it pass. Now you can create Python main. So this is basic thing like this. This is the Python main, and here I can say app.run. Oops, not app.run. I just call man. Okay, now in this main you can implement your all UI logic. So the first thing could be using Streamlit title, crop yield predictor, or let's say this, and then you can pass also subheader. You can pass anything. So if I just run and show you how it looks like, you can go to your terminal and by typing Streamlit run app.py. Now here app.py means your app.py file. If in your case it is main.py, then you have to type here main.py. Okay, so let's see. So as you can see, it's been opening in our Chrome browser. As you can see, this app is running on this local host 8501. So yeah, this is the app. Now here we need to get all the input features like area. So what you can do, you can use a variable area, then Streamlit.input text method, text input, and here you can say enter area. The second was, I think it was crop. So you can say text area, or even you can use drop down, enter crop name. So if I just quickly show you by refreshing that how it looks like. So as you can see, we have now properly two text input fields. Okay, so let me quickly add all the remaining input fields. So here as you can see, we have the same main function where we have title and subheader, or you can directly use the write method. Then we have area input field, item input field. Now for here, instead of text input, you have to use number input, because for here you have to type number. Okay, these are some built-in parameters that you can use or mention. Then we have used number input for average rainfall, pesticides, and average temperature. So once you get all these 6 values from user in real time, then we are creating a button with the help of if Streamlit library dot button, and if someone click on this button, we are triggering this function. Now this is the same function that we have used in Jupyter Notebook. So I can paste it right here. First, right after the imports, we have loaded the train pipeline with the help of pickle.load. Okay, and this is the pipeline. Now this is the same function where we are getting all the input feature including pipeline. Then we are going to create a data frame, and then we are going to predict with the help of train pipeline, and we are returning the predicted value or crop yield. So here what will happen once the user enter all the values and click on this button, all the data, as you can see here, we have called the above function, we have passed all the data. That function is returning us the predicted yield. Once we get this yield, then we are going to use success method, streamlit.success, and we are printing that predicted result. Hopefully you get the flow and implementation of this project. So now let me quickly refresh, but before entering the value, let me show you my GitHub link for this project. So this is the complete repository for Scikit-Learn, machine learning for Scikit-Learn playlist, where we have from lecture 1 until lecture 19. But for some reason I couldn't upload lecture 19, which is actually this one. So you will get directly the file. Lecture 19 Jupyter notebook file, you can use this file, okay, and lecture 19 app.py file, which is actually this one, okay. So I just wanted so that you might be confused while getting these files, but yeah, you can see these are all the previous lectures and tutorials, but for today you have to get this too. You can also get this requirement.txt if you want to directly install all the tools and libraries that we have used right here. So as you can see, this is the app. Let me add let's say the default value. These are the default values where we have Albania, Maz. By the way, if in the data set there are not all the countries, you can use another data set, okay. But yeah, these are the values. Let's see what the model is. So for this area with corresponding all the features, the model has predicted 39,602.73 yield for this area, predicted yield by the model. An end-to-end project using DB-scan clustering technique. So this will be a movie recommendation system using IMDb movies rating data set. So here you can see we have this Streamlit based web app where we have a drop down for movie title. So from here you can select your movie. Let's say I'm going to select this movie, 21 grams. So the moment I click on this recommendation, based on their similar group or cluster or some kind of similarity, my system will recommend me top 6 movies. So let me try some more. Here, by the way, you can also type like the game. So let me click. As you can see, we are getting top 6 recommendation for this movie, which is the game. So let me try some more. Let's say night, The Dark Knight Rises. So let me click on recommend. As you can see, The Dark Knight, The Prestige. So The Dark Knight Rises is related to horror movies, and you can clearly see we are getting all horror movies. So from the same cluster group. So it's mean that we are getting a correct recommendation. So this is an end-to-end project using DB-scan algorithm. So now we need to start this project implementation. So first thing first, we need to import pandas as PD. We also need to import NumPy as NP library. Now we need to import some scikit-learn classes. So from sklearn.featureExtraction.text, we need to import tfidf. Now since we are going to use movies features for similarity and similar groups clustering, we need like movie title, description, brand, all those things. So we need to get that text into a number, and for that you can use technique like TF-ID vectorizer, which is basically feature engineering technique, and we have seen this technique in detail in this same playlist. So you can follow that playlist, then you will be able to understand what is TF-IDF and how it convert textual data or words into numerical representation, okay. And from sklearn.cluster, we need to import this algorithm, which is DB-scan, okay. Okay, since before passing the data to dbscan, I would like to reduce its dimension. So from sklearn.pca, yeah, basically decomposition. You will understand everything in detail, but yeah, you have to follow exactly what I am doing. So from sklearn.decomposition, you need to import PCA. Now PCA is an algorithm which stands for Principal Component Analysis. It is used to reduce your dataset dimension. We will see it. Lastly, we need to import cosine similarity from sklearn.matrices.pairwise. We need to import cosine similarity. But before running dbscan, calculating PCA and cosine similarity, we need to scale the data set. So that model give equal importance to each word or each value. And for that you can import, as we have seen a lot, like min-max scalar or standard scalar. So let's try standard scalar. So yeah, now let's quickly it should be, I think, import. Now let's quickly load the data set. You will get the data set on GitHub account I have shared with you. Let me remove this from here. So this is the data where we have 1000 movies record from IMDb website. So here you can see we have poster link for that movie, drama or series title, released year. It's mean that this movie, the Shawshank Redemption, was released in 1994. Certificate, runtime, genre like drama, crime, action, crime, drama. This is quite interesting and important column for calculating similarity between movies. So we will use series title, genre, IMDb rating, overview, and star 1, star 2, star 3, star 4. These are the main important columns for recommendation system. Okay, so I hope you understand the data set. These are all the features of the data. Now if I just show the shape, you will be able to understand properly. We have 1000 movies with 16 features. Now as you can see, we need to create a new column where we have for each movie we have that movie title, overview, and all the stars. So what I can do, I can create a new column by name of content, and here I can say that df series title concatenate with this space. This second one was, I think, genre, which is quite important column, and also concatenate with this space my third column, that is overview, and let's say all the stars. So now you can see we have a new column where we have a complete detail for each movie, like that movie genre, that movie overview, that movie director, star, like the actress and actors, all those stars. Now if I just show the new column, which is content, for each movie you will get a detail where we have genre, overview, and all those. But we need to make all these letters in lowercase so that model do not confuse between the same word just because of uppercase and lowercase. So you can use this code like content.str.lower, and if I just show it now, you will be able to see the new column in lowercase. Now we have this new column. So what we can do, we can do some feature extraction. So just let me zoom in a bit. So since we have already TF-IDF, here I'll pass top words, English, and max features will be 300. What does it mean? I'll show. But let me create an object by the name of TF-IDF. Now let's apply this TF-IDF by calling fit transform method on our content column, because we are going to create a vector for each movie. that only will be able to calculate similarity or create clusters. Because this is text, we need to give some value to each word. And this will be my overview TF-IDF. Okay, like overview TF-IDF. So now if I just run by calling overview TF-IDF dot to array, you will be able to see this array. Now this is the first movie vector where we have 300 words, 300 dimension, or you can say features. Okay, because here we have set max feature will be 300. If you are getting max value, it means that this word is important within this list. If you are getting some 0, then it means that this word is not important. So overall, as you can see here, just let me show you. That was the first movie, and for this we have this vector. Okay, and this is the second movie detail, and we have created a vector for that movie as well. So now we have properly this overview TF-IDF. If I just show you the shape, like shape, as you can see, we have 100 vectors, like 100 movies with 300 features. Each vector has 300 words, 300 features with numerical representation. Now I will add one more feature, which is basically IMDb rating. So what I can do, I can use np dot horizontal stack. Just let me pass the code. This is the code, and let me remove this. So here you can see first we have created transformation. Now within this np dot hashtag, within a list we have passed two things. First, all movies rating. Second, all movies vectors. Now finally we have these features. So if I just show the new shape, you will see 301. Now for each movie or for each vector we have 301 vectors, and each vector has 300 words, and one will be the rating. Okay, if you want to view, you will be able to see like this. So now finally we have this feature and this overview TF-IDF. Now you can directly go and run your DB scan on this data, but you can further reduce this data from 300 to 50 by capturing most important feature using PCA. So what I can do, first let's scale this data between the range of 0 and 1. So since we have a scalar, let me call scalar standard scalar, and here let's apply the standard scalar by calling fit transform method on our features, and this will be our features scaled. So if I just show features scaled, you will be able to see sorry, this should be scaled. You will be able you will be able to see between the range of 0 and 1. Yeah, now I don't want to keep 300 features for each vector. I want to reduce to 50. So you can use PCA, we have already imported, by calling number of components will be 50. So this will be PCA, and now let's apply PCA on this final array. So PCA dot fit transform by passing features scaled, and this will be my, let me pass this code. So this will be my final features reduced. So let's run it, and now if I just show features reduced dot shape, as you can see now we have 50. So now let's apply DB scan on this final data, which is feature reduced. So since we have seen in previous video DB scan, and here basically you pass two parameter, which is epsilon. Let me start with 0.5, and mean sample, let's say 10. Yeah, or let's say epsilon. Let me try. You can change this value by doing some experiment, but there is another parameter which is known as matrix. Here you can pass either cosine similarity or Euclidean. For calculating similarity between two vectors, you can use two types of similarity, Euclidean or cosine similarity. So let's try Euclidean. Okay, so Euclidean, and this will be my db scan algorithm object. Now let's apply this db scan dot fit transform on features reduce data, and let me create a new column by the name of cluster in my data set. So finally we have this new column, and let's see how many clusters we have generated with the help of db scan. Now here you can see we are getting basically 3 clusters. This is outlier, this is original cluster, and this is also original cluster. What if I just rerun all these things? But yeah, I think you can change this value accordingly and rerun. You will get some different results. But yeah, finally we have this data with the new column cluster. Now all the similar movies based on their feature will be put in 0, and all the other similar movies that are similar based on their features, genre, all those things will be put right here, and some will be here. Now before creating the web app, let's try a new movie. So I'll create a function by the name of recommend movie. So here it will take a new movie title, our dataset, overview, or trend overview TF-IDF, and default parameter by the name of recommendations. So let's say 6 recommendation we want for the new movie. First I'll check if this new movie is present in my data set. So I'll check if it is not present. If the title not in df series title dot values, then return that movie not found in database. Try again. But if it is, now for this new movie, first we will, if this movie is lies in this cluster, then we need to get this cluster label. But if this new movie is lie in this cluster, then we have to get this cluster label. So what you can do, you can say that cluster label, and you can filter that based on this logic. Go to the new column which was cluster basically. If it is equal to the new title, then get its value. Okay, let me try the function that if it is working or not. For now let me just return cluster label. Now let me call this function which is recommend movie. Okay, and let me pass a new movie, let's say The Dark Knight, and here let me pass df here and our trend or view TF-IDF. So let's run it. So this movie is not present in our entire data set, that's why we are getting this message. But if I just make it like night, again we are getting the same message. Let me paste this title which is actually present in my data set, but let's see. Okay, we are getting some index 0 is out of bound for x 0 is size 0. Let me rerun. So here you can see it's cluster. Okay, so we are getting it. Now we will filter out all the movies that are present in this cluster which is 0. Okay, so how you can do, like cluster movies, then we can go to cluster, and here we can compare if it is equal to cluster label. and in that case we will be able to get all the movies that are present in the same cluster for the same new movie title. So if I just return cluster movies and let's see what happens. We are getting error. Lens must match to compare. I think I have to pass this. Index 0 is out of bound. I think I'm doing some mistake right here. Let me paste, by the way, this code I have already implemented. So now if I just return cluster movies and call the function which is recommend movies, and if I just pass title like The Dark Knight, and here I pass df and run it, so you can see we are getting all those movies. For now, if I just fetch like series title, so these are the movies that are present in the same cluster that we have fetched for this new one. So these are the most similar movies to this one. But what we can do now, for now we just get the same cluster movies, but now we need to calculate within the same cluster with all these movies. We need to calculate cosine similarity of this new movie. So first we need to create vector. Since we already have this vector, I can say movie vector or vector movie. Let's say movie vector. Then since we already have all vector stored in OVTF-IDF, so here based on this logic, which is the series title, that is equal to my one, which is the new one, and its index, based on its index I am getting this new movie, let's say this one vector, its numerical representation. So finally we have this vector. Now we can use cosine similarity in real time for this movie vector with all other movies, which is an array of overview TF-IDF. But since it has more cluster, so we need only that cluster where are this new movie and all the extracted movies are present. So here what we can do, we can say that cluster movies based on their index. So here this is the new movie, which is actually this one. We have created its vector, and these are all the movies that are present in the same cluster where we have this movie. So since it will return 2D, but we need 1D, so you can call flatten. So this will be similarities. Now based on these similarities, I will fetch top 6 similar movies and their details. So this is the final code. Let me paste and let me explain. So basically we have this function where we are getting a new movie title or data set and default parameter. First we are checking if the new movie title is not present in our data set, then return this message. After that we are getting that cluster in which this movie is present. So if this movie is present in 0 cluster, then we are getting 0 label. If it is present in 1 cluster, then we are getting 1 label. Now based on this label, we are getting all the movies that are present in the same label, so that we can check similarity. So here current movie, which is the title label, and all other movies label. Now after that, now we are going to calculate similarity between this and this. So we need to create a vector. So based on this label for the new movie, we created vector just by taking from overview TF-IDF, and then we have passed cosine similarity, our new movie and all the similar movie that are present in the same cluster. So finally we have this similarity. Now based on this similarity, we have called argument sort, and we have passed all the number of recommendation, which is basically 5 or let's say 6, and we are getting their indices, and based on these indices we are going to cluster movies, and from that from that we are getting this details like that movie title, overview, and all those things. So now if I just run, you can see we are getting series title, overview for this movie. If I just copy this movie and paste it right here, and let me change the movie to network, so you will see some similar movies. So here The Wild Punch, The Bridge and the River Kwai, The Shawshank Redemption, Braveheart, Dark City. So here you can see we are getting a recommendation. So now we need to create web interface for this, but you need to save few things, like you need to save the data. So df.tocsv, and you can say like cluster df.csv, and here you can say that index will be false. And one thing more, we need to also save our view df-idf. So import pickle library. This will help you save that file pickle, and then you can say pickle.dump, and here you can say overview df-idf, and then open, and you can say by the same name overview df-idf.pkl, but here must be a write binary mode. So once you run it, you will get your cluster df and you will get your overview df-idf. So now we are ready to create user interface. So I am using PyCharm IDE. You can use any IDE like VS Code or any other IDE. But in this folder you must have created virtual environment, and you must have this cluster df, and you must have overview df-idf. Now first thing first, go to your terminal. If you have created virtual environment, it will look like this. Then you need to install like pip install Streamlit, Scikit-Learn, Pandas. So you need to install all these three libraries. The moment you enter, it will be installed. So let's quickly import Streamlit as st, and then import Pandas as pd, and then from sklearn pre-processing, sorry, we just need matrices pairwise import cosine similarity, right? And also import pickle, and also import numpy. Yeah, now let's load save data and overview df-idf. So df-pd.read csv, and here I can say clustered df, and let's also load overview df-idf by calling pickle.load, and here you can pass open, and here you can give the path name which is overview df-idf, and here this time you have to set read binary mode instead of a write binary mode, because this time we are loading. So yeah, this is the code. Now let's create Streamlit UI. So what I can do, first I can say streamlit.title, and here I can say movies, movie recommendation system. You can also do something, but we will see that later. But if I just run it and show that how it works or how it looks like, so in terminal what you have to do, you have to write streamlit run app.py. The moment you enter, you will be redirected to your web app or user interface. So it's loading. So as you can see, movie recommendation system. Now what we can do, we need to take movie title as an input from user, but what we can do, I can say that movies title, because I'm going to create a drop down. Instead of typing, we need to give this facility to user as a drop down. So df series title, and then first I will sort them, sort values, and then I will get all the unique. So after that I can say that streamlit dot select box, and here I can say select movie like this, and here I will pass all the movies title. So now if I just refresh, then you will see. So here series title is a spelling mistake, I think. So it must be title, series title. Now you can see we have a drop down. If I just click, you can see we are getting all the movies. You can also type, if I just say like the kid, as you can see we are getting. So now we need to create, or let me test this code. It's basically just the same code, but now here I've first set the page configuration. By the way, you'll get the same result, but more centered and more attractive. So these things could be changed accordingly. But now we need to add a button. So if st dot button, let's say by the name of recommend, if someone click on this button, then we need to get all the recommendations. So we have a function that we have seen already, recommend movies. We have to pass this selected movie, this one. If user select movie, we are getting right here in our loaded df. So it will return output or recommendation, output like this. Okay, now we need to use this function. This is the same function that we have seen in Jupyter notebook. So here right above the UI I can paste the same function. That is the same function, as you can see, recommend movies. So here we are calling this function. Now if I just print by using st.dataframe function of streamlit library by passing output, you will be able to see the result. So let me refresh and let me select this after hours movie, and the moment I click on the recommend button, we are getting series title overview. This is the data frame. Okay, but if you want to display proper view, you have to do some custom code. So what we can do, first I can check if is in instance is output with str, then it's mean we have some errors for this output. So instead of that, what we can do, we can say that st.error, we have to display it's basically mean if we are getting this recommendation with some errors, then we are going to display errors. Otherwise, if we are getting proper df of recommendation, then in else part we need to display 3 by 3 movies. So since we are getting 6, so in first row I am going to display 3 movies, in second row I am also going to display 3 movies. It's mean 2 by 3. So here I can say that for I in range from 0 till length of output, and here I can also say with 3 step, and then we need to create column. So if in first row we are going to print 3 movies, then we need 3 calls. So call, for that you can use streamlit dot column with 3 values. So if I just paste this, so this is the code. Now try to understand this code. So here on click of button, we are getting all the recommendation for the selected movie. First we are checking if we have some error. then sorry, I was getting some messages on my phone, so I distracted. But yeah, when someone click on this button, then we will get the recommendation. If we have some error related to string or int, then we will display some error, but otherwise we are going to create rows accordingly with 3 columns. So in first row we are going to display 3 movies. Again we are running a loop with range 3 because I'm interested in 3. So here with this logic, I'm creating a row, and with calls based on this J, I'm basically displaying that movie with poster using streamlit like markdown, image, right, like IMDb rating, overview. For overview, I'm just displaying first 50 letters. So these are the entire flow of the project. It's quite simple. Once you get all this code, you'll be able to understand, but just let me quickly show you. If I just select this movie, AK in the whole, so now you can see we are fetching. This is the first row where we have 3 movies with title, poster, IMDb rating, overview. In second row we are also getting 3 movies. So that was the beauty of the custom code. So let me try some more. As you can see, where we are going to classify a pair of sentences. We will be discussing this project and we'll be seeing its output. Let me quickly show you. So this project is an NLP based relationship detection system that basically classifies the relationship between 2 given sentences. As you can see here, we will provide 2 sentences. As in my case, I have these 2 sentences. The dog is running in the park, a woman is running outside. Then what will happen? The model will determine whether the 2 statements support each other, like entailment, or they conflict with each other, like contradiction. Okay, so it is particularly useful in application like question answer system, information retrieval or validation, and logical consistency checking. Okay, so this is quite beneficial for you if you are new to NLP, and especially pair sequence classification. So what will happen once you click on this button? The model will tell you either contradiction or entailment. Here contradiction means that there is a conflict between these 2 sentences based on their semantic meaning and relationship. You can clearly see there is a lot of difference between these 2 sentences. Okay, so here contradiction means conflicts between these 2 sentences. Now what will happen if I pass? So a woman is jogging in the park, a woman is running outside. You can see the structure and word combination could be different, but overall you can clearly see there is a relationship between these 2 sentences. So let's see the model. As you can see, the model is also predicting entailment, which means there is a relationship between these 2 sentences. So yeah, this is the project. Now this is an end-to-end NLP project. First we need to load the data set and do pre-processing, and then we will train a couple of classifiers, and finally we will be selecting a best one model, and then we will be deploying that model with this simple user interface. So let's get started. So we are going to use this stand for Natural Language Inference Corpus. If you click on this link, you will be redirected to Kaggle. So you can directly download from Kaggle the data set. Let me quickly show you. So if you scroll down, you can just click on this train set, and once it load, then you can click on this button so that it could be downloaded. You don't need to download all other sets. We will be just using this train set. Okay. Yeah. Now the first thing, always you need to load data set. For that you need pandas library, then read CSV, pass the path of your dataset. Now since in that dataset we have a lot of columns,
But what I want to use in this project, I'm just interested in sentence 1 column, sentence 2, because this is the pair where I'm going to check the relationship or contradiction, and this is the label where we have 3 classes. So if I just show you, let me rerun. As you can see, we have this data set where we have sentence 1, a person on a horse jumps over a broken down blah blah blah. A person is training his horse for a competition. It's basically neutral. But if there is a contradiction, then you will be able to see a contradiction label, and if there is a relationship, then you will be able to see entailment. Okay, so since this is quite big data, it's almost 5 lakhs, I think 50,151 rows, or you can say documents or sentences. So what we can do, we can just take a subset. For that, you can call a sample method, and there you can pass this sample as you want. So for now, I am going to use for this project only 5,000 sentences or rows. Okay, so if I run it now, I have only 5,000 records. Perfect. Now we need, as you might be familiar with NLP project, text cleaning. Now there we have, for the first step for cleaning NLP text, you have to bring all the words or letters in lowercase, and you have to remove stop words. There are more steps like removing punctuations and removing HTML tags. There are a lot of steps, but for now we are just going to remove stop words and bring all letters into lowercase. So what we can do, I can just call sentence 1 column. This is my sentence 1. Then I'll just call apply method. There I can use Python lambda that will take row, that will take first document or first sentence, and then I can simply say dot lower. Okay, so if I just run it, now you can clearly see we have all clearly bring all letters into lowercase. But before that, from Scikit-Learn dot feature extraction, we need to import stop words. So go to text, and there you have to import English stop words. So since this is English text, and we have already a built-in class where we have stored all the stop words, so we can, with the help of this, we can easily remove all the stop words. Okay, so let me quickly do that. So here you can see, first we imported English stop words, then we have performed lower casing on both input columns, and thirdly what we have done the same in the same way like using lambda, but this time you might be see the code a little bit tricky because I am going to use one line code of Python. So first I'm just running a loop on the entire text. First it will take this, then this, then this, then one by one I'm getting word. So first it will get this word, then this word, then this word. Then I'm checking with the built-in class. If it is stop words, remove it, otherwise pass it and store it right here. So finally, if I just show the new data, this will be a clean version where you have all the lower letter cases, and we have also removed stop words. Now the last thing before trend test plate, if I just show you label and call value counts, as you can see we have 3 classes. So let's make it a binary classification. Let's remove neutral, we don't need it because we are interested in contradiction and entailment. Okay, so you can do filtering df, then you can call the label column, and then you can do some condition. If it is not equal to neutral, then get or filter all those data. So basically we are going to filter all data except neutral. After that, I am going to combine both sentences, because after all a machine learning model needs a single column as an input. So I am combining these 2 sentences as a single input. As you can see, now we have new column. So let me run it. So finally I have this input column, and this is my corresponding target column, which is label, where we have 2 classes, entailment and contradiction. Now let's quickly do trend test split. So this is quite simple. If you have watched this playlist, then you might be familiar with train test split function. Then I've explicitly taken input into X and target into Y. Then I've called train test split by passing input and corresponding Y with these parameters. So 80% data will be stored for X train and Y train accordingly, and 20% data will be stored in test sets. Okay. Now, since as you can see, this is a text, we need to convert it into a numbers or unique IDs. This is known as text vectorization or text transformation in NLP, and I have already created 2 videos in the same playlist. For that, you can use a lot of techniques in NLP and Scikit-Learn, but as we have seen in the previous video, TF-IDF vectorizer, we will use the same. Okay. So if I just show you xtrain, as you can see, I think I have to run this, and then I have to run this. Okay, let me rerun, and now let me run this. As you can see, this is text. So for each sentence we will have a vector, and there you will see some numbers for each word. So what you can do, you can just go to feature extraction.txt, and then you can import TF-ID vectorizer. Then you can create an object, as we have seen all these things. Then you can apply this TF-IDF on input xtrain and xtest. So finally you will be able to see xtrain TF-IDF and xtest TF-IDF. Okay, because this is this will be the final data that we will be using for training the model. So if I just show xtrain TF-IDF, and let me also explicitly convert it into array. As you can see, this is the first sentence or first document. There you will get zeros and some numbers. If you get a higher number, then it's mean that that word is important for this document. If you are getting 0, then it's mean that word is not important for this document. Okay, so basically that was text transformation or vectorization. Okay, now let's train couple of machine learning models, and let's also evaluate. Now we have already seen how you can train classifiers in machine learning with Scikit-Learn in the same playlist in couple of videos. So let me quickly implement. So as you can see, I am going to use logistic regression, random forest classifier, support vector classifier. So you have to import accordingly. Now since these are classifiers, so we have to evaluate. Then for that you have to import classification report and confusion matrix. And these are 2 libraries that you can use for visualization. Now since I am going to train 3 models, so instead of training separately, you can train at once using loop. So I have created this list where I have a name and that model as it is. Then I have run a loop by taking name and model, and then I am training, evaluating, printing classification report, confusion matrix, and also plotting. So if I just run this cell, so for logistic regression, you can see the classification report. Overall accuracy is 60, which is not a good, but still this could be a good sign for, since we are just using 5,000 rows, you can use 20 or 25. And this is also a pair of classification, so in that cases you might be not getting a higher accuracy, but yes, for new data it will work. And this is the confusion matrix where you can check model correct classification and misclassification. I have already discussed all these things in previous a lot of videos. This is the second model, which is random forest. So random forest has 65, and you can also see its confusion matrix. Then we have support vector machine with 59. So either you can go with logistic regression or random forest. So let me quickly train separately the best model. So here I am going to train logistic regression separately and then evaluation. So let me run it. So logistic regression has given us 60 accuracy. Now let's create a detection system. As you can see, I have these 2 new inputs. A man is playing a guitar, a man is riding a bike. So let me create a Python custom function by the name of detect. This function will get input or sentence 1, sentence 2, the train model, and train TF-IDF. Okay. And the first thing I have to do, I have to combine this two inputs, combined inputs. So input 1, I can combine them by using like this, and then we have to transform this input using the trend TF-IDF. So there you can just call transform method, and you can pause this combined inputs, and this will be my vectorized inputs. Now let's finally do detection. So we have a trend model, then just you can call predict and pass your vectorizer data. So it will return a prediction. So let me quickly paste this structure code. So this is the same function where first we are combining, there we are performing lowercase. By the way, we also need to remove stoppers because our model is trained on such data where we have removed stoppers. But for now, let's do prediction. Then we have transformed the text into numbers, then we have done prediction. So finally we call this function right here, and we are printing the result. So let me run it. So as you can see, we have these two sentences. Now let's see. The model is predicting contradiction because there is a contradiction between these two documents. I have another two documents, and for this the model is predicting entailment. It means that there is a relationship, because clearly you can see we have a relationship. Let's see, there is a contradiction. A little bit, it should be neutral, but yeah, because of the, or it could be entailment, but model predicted contradiction. And finally we have these two documents, and there is a clear relationship, so the model is also performing entailment. Now finally what we have to do, we have to save the train model and train TF-IDF, because we are going to create a user interface and do integration this model with our app. What you can do, you can use either joblib library or pickle. So with the help of pickle you can easily save your model and TF-IDF on this path. So if I just go to my models, there we go, we have these two files. Okay, so you can use either VS Code or PyCharm, whatever you want, but go to your terminal and you need to install Streamlit library. So pip install Streamlit Scikit-Learn. You need to install these two libraries. Okay, so import Streamlit as st. Then let's create UI. So first let's create title. So streamlit.title, and there you can pass pair of sentences detection. You can give some more appropriate title, but for now let me make it like this. Now let's take two sentences. So sent one, then I can use Streamlit library dot input text or text input. Enter sentence 1 and sentence 2 st.text input, and then enter sentence 2. Okay, now I also want to create a button. So if Streamlit library dot button, if someone click on this button, let's say detect, then we will do something. So for now let me quickly run the app. So what you have to do, you have to just go to your terminal by typing Streamlit run app.py. Once you enter, your app will be automatically pop up in your Chrome browser. Okay, as you can see, we have input 1, input 2, and this is the button. Now we need to load the save model and TF-IDF vectorizer from models folder, and we also need the same function that we have used at the end of Jupyter notebook, because that is the function that is used to predict for new data. So what you can do, you can paste this code. By the way, I am going to share all this code. So these are the two modules that we are going to use. So we loaded both models with the help of load. model and TF-IDF, and we have saved accordingly. This is the exactly same function where we are passing two inputs with model and TF-IDF. First we are combining, then we are performing lower casing, factorization and prediction, and finally it will return at the same time either entailment or contradiction. So the code is pretty much similar as we have seen already, and it's quite simple. Okay, so here this is the title, these are some paragraph just to make the app more realistic, and these are the two inputs we are taking from user in real time. Once the user click on predict button, then we are calling the function, which is actually this one, and we are also passing the two inputs, and it's return basically the prediction, and then with the help of success method we are displaying the result whatever the model predicted. So this is the flow basically. It's quite simple. Once you implement each line manually, you will understand everything. So what I can do, I can just refresh the page. Let me add a couple of just let me show you as we have already seen. So these are the two sentences, and the model says that there is no relationship between these two documents or sentences because there is a contradiction based on its semantic meaning and logic. So since this is not a good project, honestly speaking, since we are using a trained model only with 60 or 65 accuracy, but for educational purposes and especially NLP based project, and especially how you can do a pair of sentences. Normally in NLP you will be getting a single input, either text or comment, whatever you are doing, like sentiment analysis or text classification. But sometime you will be doing a pair of sentences or documents, or maybe 3 documents, or maybe 4. So the flow will be similar. Career aspiration predictor for students, like based on student gender, math score, I mean all subject score like history, mathematics, physics, chemistry, part-time job like yes, no, extra activities, weekly hours rate, total score, then we will tell or we will predict for that student a most recommended career. Okay, like doctor, teacher. So as you can see, by default I have this values. Now I don't know, once I click on this button, what will the model recommend for the student. As you can see, constructor engineer. So let's increase some value, like there is a student female in mathematics, that girl achieve, let's say 99. Let me quickly give 99 to all subjects. So, and 99 in physics, chemistry 99, biology 99, English 99, and geography, let's say 90. And weekly self-study hours also increase because this is a talented student. If 99 total 7 subject, then it must be like almost 600, let's say 90. And yes, part-time job, yes, extra activity, yes. So the student is quite talented. Now let's see what the model recommend. Doctor, as you can see, for doctor you must have 90 at average score. So once you calculate this score, you will get 98 average score. So you can see we are recommending a career for student based on their records. So let's get started. First thing you have to do while doing with the project, quickly do some imports like tools, numpy as np, then pandas as pd, then some pre-processing tools like from Scikit-Learn dot model selection. It should suggest me, yeah, and then import trend split. Okay, and we also need from Scikit-Learn dot pre-processing, we need to import for encoder, let's say label encoder, and for scaling we can use standard scaler.
Okay, and from balancing the data set we need from sklearn dot utils, we need to import a resample class. So yeah, import resample. Now let's import quickly few classifiers, like from sklearn dot linear model we need logistic regression, linear model import logistic regression, and from sklearn dot tree we need to import decision tree classifier, and from sklearn, so let me quickly import all the necessary tools that we need. So as you can see, we imported pandas and numpy, then pre-processing tools. Now these are the classifiers that we are going to use for this project, like regression, support vector classifier, random forest classifier, canary neighbor, decision tree, Gaussian NV, ADA boost classifier, and gradient boosting classifier. Now once we train this classifier, then we have to evaluate like confusion matrix and classification. So for that we imported accuracy score, classification report, and confusion matrix. So let me run this cell. Let me rerun. Now let's quickly load the data set. So df pd.read csv. So you will get the link of this data set in the video description, that is student score. Now if I show the data set, as you can see, now in this data we have a student ID, student first name, student last name, email, gender like male or female, part-time job, which has two values, true and false. True means yes, that the student has a part-time job, and false means no. Absence days, extracurricular activities, yes and no. Weekly self-study hours, career aspiration. Now this is the target column that we are going to classify or predict based on all the other input features. Math score, history score, physics score, these are the subject in which the student has achieved its score. Chemistry, biology, English, and geography score. Okay, so basically this is a supervised learning problem because we have a label data. Label data means that you will have all input features with corresponding target column. And for the supervised learning problem, we have further two types, regression and classification. So this is a regression problem because if I show you df career aspiration dot value counts, you will see that we have almost 15 classes, right? So we have 15 classes, so it's multi-classification problem. Okay, so let me quickly remove irrelevant columns, like we don't need to use this column as an input. So you can use drop method, which is quite simple. So what you have to do, you have to call the data with drop method, and you have to pass all the columns like ID, first name, last name, and email. In place will be true, that we want that to drop it for basically we want permanently, so you have to pass in place as a true. So now we have this data. Now in this data, as you can see, gender, part-time job, activities, and career aspiration categorical columns, because these columns have categories, so we have to encode them, like for male and female 0 1, for true and false 0 1, and for career from 0 to 16, because total we have 16 classes, because machine learning model can only understand numbers instead of categories or text. So but before that, if you want to create more features, like if we add all student subjects and create two columns, total score and average score, which is quite simple. So what you can do, but before that, let me quickly show you missing value in the data set. So you can use is null.sum method. So we don't have any missing value. Now if I create a new column by the name of total score, or you can give total subject score, and then if I call the first subject, which is math score, then history score, right? So math score, plus history score, oops, df history score, and all the other columns. So as you can see, we have added all subject score, and now we have another column by the name of total score, in which for each student we will have total score. Let me create another column, average score. So for average, you have to divide this with all the subjects. So total we have 1, 2, 3, 4, 5, 6, 7 subjects. So we have to divide total score on 7. So what you can do, you can just call total score column divided by 7 and store in new column. So if I run this cell, you will get a new data set with these two features, total score and average score. It will further improve your model performance. So this is known as feature creation or new features, create new features. Now let's encode quickly gender, part-time job, and career aspiration and activities. So for that we can use label encoder, but what I will do for gender, part-time job, and activities, I will use label encoder, and I will encode career aspiration manually. Okay, so let me quickly create a let me first create an object by the name of encoder, and let me call label encoder. Now we have to pass calls will be equal to encoder dot fit transform method. Instead of calls, what we can do, we can pass directly column like gender, part-time job. So let me quickly do. Or what you can do, you can separately apply on each column. Like if I call gender and then encoder dot fit transform and pass gender column, right? So it will encode male and female into 0 and 1. So let me quickly do for gender, part-time job, and extra curricular activities. So now if I show the new data set, you will see, as you can see, in gender now we will have two values, 0 and 1. 1 represent male, 0 represent female. Part-time job will have two values, 0 and 1. 0 represent false, it's mean no, and 1 represent true, it's mean yes. So now let me quickly also encode career aspiration. So what you can do, you can do this code, df.career aspiration. You can call Python map function and pass a dictionary like I want lawyer to 0. So you can do like a lawyer will be 0, and let me quickly do the other classes as well. So let me paste this code right here. So as you can see, what we have done for career aspiration, all the classes have been successfully encoded. Like software engineer will be 0, business owner 1, unknown 2, banker 3, this. So total we have 16 classes, and again we have stored in career aspiration. So if I show the data set again, you'll see now for career aspiration we have encoded classes. So we are almost ready. Now the last thing we have to do, we have to scale all the numerical columns so that we further improve our model performance using standard scalar. Yeah, so now one thing why we do scaling in machine learning, as I have already mentioned in this playlist, scaling is important because sometimes what will happen, if you have larger values like 100, model will give higher importance to this value in comparison to lower value. So if you want to make the model balance and model give equal importance to all values, either lower value or higher value, then we have to bring all these values between the range of 0 and 1. So here let's create an object by calling standard scalar, and let's call scalar and fit transform method and pass all the column that we want to transform. So I can create a list of all those columns right here. So now you can see we have these columns that we want to scale, and we have this object, and then we have call fit transform, and we have pass all the columns, and accordingly we have store right here. So if I show, now you will be able to see, as you can see, now you will have values between the range of 0 and 1 for each numerical column, as you can see. Perfect. So now we are ready to train model, but one thing we have to balance this data set. So again, in this playlist Scikit-Learn for machine learning, I have already mentioned that why we need to balance data set and how to do. But let me call the target column, which is career aspiration, and let me call value counts method. So you can see there is a class 0 which has 315 records or rows, and there is another class 16 which has only 32 rows or records. So if you train any machine learning classifier or model on this data, then the model will try to buzz toward majority classes, higher classes. It will skip those classes that has lower values or lower records. So if you want, again, for classification or for classes that the model must give equal importance to each class, then you have to balance this data set either by using oversampling technique or undersampling technique. So let me quickly use oversampling techniques. We have to bring all these smaller classes like 315. So each class must have 315 records. Okay. So for that we have a resample method that we have already imported from Scikit-Learn. What you have to do, you have to pass couple of things: your data set, entire data set, and sample. Okay. Basically number of sample I want 315, and random stat will be equal to 42. But first let me quickly get all the unique classes. So df carrier aspiration dot unique. So if I run, let me remove this thing, and if I call classes, so as you can see we have all these unique classes. Now let me also get data set list. So df list, I can run Python list comprehension, like for label in classes, and then I can do filtering like this. So if carrier aspiration class equal to this label that we have extracted, then get the data and store right here. So now this time you will get a list of data set instead of data frame. This is important because we have to pass, there is an issue, false. I think while encoding we have skipped some value, so let me quickly rerun. Okay, I made a mistake. I have to remove this bracket from here. Okay, I think I have to pass right here. Basically let me pass this code. So if I show df list, as you can see now we have a list. Now what we have to do, I will run another list comprehension where for sub df in df list, and then I will call resample class, and I will pass my sub df and number of samples I want for each class to be equal to the maximum class, which was 315, and a random stat 42. Okay. Okay, one more thing here, you have to pass a resample will be true. This is the parameter you have to pass, and let me give it a name, df upsampled. Now for this you can use another library, imblearn, in few line of code, but since we are working with Scikit-Learn, so we need to also learn resample method as well. So yeah, this is the code, and let me also create now a data frame. So if I show the data, now we have this data, and now if I call career aspiration and value counts like this and run it, you can clearly see now all classes have equal records. And if you train an ML model on this data, then it will perform well for each class. Okay, but let me also add here another line of code, because we have to reset the index while balancing the data set. Because of this resample, we have to reset the index to 0. So you can add this line of code and it will help you reset the index. Perfect. So now we are ready, our data is balanced. So what we can do trend test split, which is quite simple. So for trend test split, you can use trend test split method, but first we have to extract all the input features, and then target column, which is career aspiration. Then we have created 4 set: xtrain, xtest, ytrain, ytest. So it will store 80% data for training and 20% data for testing. So as you can clearly see, trend shape has almost 80% data and test set 20% data. Okay, now let's train multiple model. So first I have to create a dictionary of all the classifier with the name and object of that classifier. So here let me pass this dictionary. So in this dictionary we have first logistic regression, name and its object, then support vector classifier, and then all the other classifier. Now let's run a loop on this. So we will get the name of that classifier and the model as it is on the dictionary, but here you have to call items function. So if I print name with this thing and model as it is, so as you can clearly see, we are printing name and its object. So within this loop, I want to train model by calling fit while passing my 80% data, xtrain and ytrain, and I also need to test the model. So then I can call predict method by passing xtest 20% data. Now I want to print classification report so that I can check model performance. So classification report need model those data that has not been seen by the model, which is y test, and those data that has been predicted by the model, which is y pred. And the same thing I'll do for confusion matrix. So let me quickly implement this logic. So we are almost ready. As you can see, first we are printing the model name, then for that model we are printing its accuracy, classification report and confusion matrix. So let me run it. So this is logistic regression. Logistic regression accuracy is 39 and classification report is this, as you can see. Now in this playlist I have already mentioned what is classification report and what is confusion matrix. And after that we have support vector classifier, which is performing very bad. And then we have random forest classifier, which is performing quite great, 95. And you can clearly see its confusion matrix is quite good. I have already mentioned that above diagonal if you are getting more zeros, and below diagonal if you are getting more zeros, it means that your model is not doing a single mistake. And canary neighbor is also performing good, and decision tree is also performing very well. And then so we can go with random forest. So let me quickly train random forest separately so that I can use it for prediction. What you have to do, you have to just separately train that model that you want to use for production, which is random forest. So let me run it. As you can see, random forest has achieved almost 96 accuracy with quite great result for like precision recall F1 score for each class, and you can clearly see confusion matrix. Now let's save 3 things: this model, random forest classifier, and we also need scalar and encoder for production. So for that you use pickle library. So pickle, then you have to call pickle.dump method, and you have to pass your model that you want to save, which is model random forest classifier, and open parameter where you have to give a name. So I have a folder by the name of models. You can create it manually, or you can go and let me create. You can create the folder like right here. Okay, so once you create, then you can store the model in that folder. So call that folder by which has model's name, and now give any name to your this model, like random forest classifier, or you can give like model dot, but extension must be pkl, and here you have to use write binary mode. And now let me quickly do this for scalar and encoder. So as you can see, if I run this cell, you can clearly see we have saved encoder by the name of encoder, and scalar by the name of scalar, and model by the name of model random forest classifier. So if I go to models, as you can see, encoder, model random forest classifier, and scalar. Okay. Now before creating the app, let's quickly create a function that will get new input, I mean student record, and it will predict the carrier for that student using this train models. So let me quickly load. Now for loading, you have to use pickle.load, and they are open and pass the path. But this time, as while saving, we used write binary method, but while loading you have to use a read binary mode. Okay, so let me quickly run it. And now let me create a function by any name, like student carrier prediction or something, and this will get a couple of parameters that we will see a bit later. But let me create some dummy input or new student record, so that we can check how the model predict for that record. So let me quickly create that record. So I have this new input. There is a student gender, which has male, part-time job, yes, 2 absent days. So these are the record for the student. Okay, now we have to pass all these variables as an argument to this function. Okay, oops. So let me call this function right here, and let me give it a name to this function like predict carrier. So now here you can clearly see we have passed gender, part-time job, all the variables. And if I create the function right here, we also need to get all these variables as a parameter right here. Okay, control V. And now within this function we need to create a data frame for this values with column names, because there are different columns, categorical, because for model we need to convert this into 1, and this also into 1, this also into 0, and we also need to encode this, scale these values, because during training we have used encoding and scaling, and you also need to do the same thing while prediction system or production system. Okay, so creating a data frame is quite simple. You can use pandas data frame, and you can pass a list of all these variables. So let me quickly create that. So I can paste this code. So within this function we are creating pandas data frame while passing all the data, and we are also creating column names for that values, and this is the input data. Now for the first thing we have to encode gender, part-time job, activities, okay, by calling encoder. But this time what you have to do, call encoder.transform method, because this encoder is already trained and we have loaded right here, as you can see. This time you don't need to use fit transform. Fit transform only used for the first time while training that encoder. But once you train for production or in prediction system, you have to just call transform. Okay, and here you have to pass input data columns. Okay, so let me quickly do that as well. So now you can see we have encoded gender, part-time job, and activities, as we have already done during training. Now let's quickly do scaling. Now as you can see here, we have called the scalar transform method, and we have passed all those columns that we want to cal, and again we have stored it in that column accordingly. So now finally we are ready with this data, so we can do prediction. For prediction you can use model random forest. This is the model, and you can only call predict method and pass your input data. Okay, so it will return carrier. So whatever value it will predict, it will return. So let me quickly test this code. So what will happen? We pass this data to our model. This model will predict one class. Total 16 classes, but it will predict one class, either 0, 1, 2, 3 until 16. And that class will be stored right here. Now what I have done, this result will have a number, but we have to display proper name like lawyer or teacher. For that I have to create career aspiration map. So what I can do, so before this function what I have done, I have created a dictionary, but this time I have put all the values before names, because this time I'm going to map these values to name. Okay, like previously before training we have done for the target column, but this time it's inverse. Okay, so once the model predicts the result, then we have passes that result value to career aspiration map. So now it will give a proper name and we are returning that name. So let me run this. Now once we call this function, it will return the name right here. So we have to print here like a recommended career, and then print the predicted carrier. So predicted carrier is this one. So let me run it. There is an issue. Maybe let me print like this. Yeah, abstract. Let me run it. As you can see, predicted career aspiration is constructor engineer. Perfect. Now let me quickly give another example. So I have this data like gender female, part-time, no part-time job, absence is very low. So this data is mostly similar to teacher or government employer. So let's see. As you can see, the predicted career aspiration is constructor engineer. Here also predicted constructor engineer. Let me quickly change some values. Let's see. So here what happened, I changed the record. Now as you can see, for this student I increased each subject score almost 100. So let's see for this student what the model recommend. So it could be a higher profession. Let's see. So as you can see, predicted is doctor, because for doctor you need 98 percentage. Here you can see percentage. So model is doing great job. Now what we have to do, we have to create a user interface for this project. Okay, so the first thing you need to open any IDE like VS Code or PyCharm, and there you must have models where we already save our encoder, random forest classifier and scalar. Okay, and you must have this virtual environment. You have to create it, and you also need to create this app.py file. So once you right click and go to new, then you can create this file right here. Now within this app.py we are going to implement our backend code, or you can say integration code. So we will use Streamlit library. Now Streamlit is a Python framework or library that provides simple user interface so that you can test your model or do some kind of analysis or prediction. So first you need to go to your terminal. So in this terminal you need to create a virtual environment. Once you create, you will see like this. Your environment will look like this. Now here the first thing you need to install Streamlit space Scikit-Learn space. I think you only need to install these two libraries for now. Okay, now let me quickly import Streamlit as st, and let me quickly import pickle, because we also need to load the same model. Now let me quickly load the same model. So for loading model, let me zoom out a bit like this. So these are the imports, and these are the three models that like random forest classifier, encoder, and scalar that we have loaded. And this is the mapping dictionary that we will be using for displaying the predicted class message. I mean, if the model predict 4, we will show the name of that 4. Okay. Now let's quickly create input fields. So first, using Streamlit library, let me create a title, student, career, aspiration, predicted, or you can give any name. Okay. Now after that, let me create. Okay, as you can see here, if I show you, as you can see here, we have side by side two input fields. This is column 1, this is column 2. In column 1 we have gender, part-time job, activities, absence days, self-study hours, total score. So we need to create two columns. So for that you can use call1, call2, and Streamlit library.columns, and there you can pass 2. Now with call1, let me first take gender. So gender value, how you can use as Streamlit library dot, since we have a drop down, so we can use here select box, and within this you can pass like select gender, and a list of yes and no, so male and female, so male and female. Now the second, let me also do for the second one. So as you can see, and for part-time job we have to use select box because we have true and false. Now let me quickly do for other input fields as well. So what I can do, I can paste this code right here. So this is the UI. Basically this is set page configuration, and this is the title, this one, and this is the markdown. And now we have call 1 and call 2. In call 1 we have gender, where we have used drop down for male and female. For part-time job we have used drop down, true false. For activities again we have a drop down, but for absence days we have used slider. If you slide, it will increase value. These are some parameters values. And for weekly study hours, we also use slider. For total score, we use number input. It means that you can manually type there. So if I run the app and show that how it works, you have to write here Streamlit run app.py. App.py is your file name. So let me run it, enter. So it will pop up your app in your Chrome browser. So let's see. So as you can see, in the first column we have these input features. Now let me quickly use the other input features in column 2. So after this column, let me pass this code. So with the call 2, we are taking subject score like math score, history score, physics, all subject scores, right? Basically manually. So we are using number input. So let me refresh. So as you can see, we are almost ready. Now we have to add a button here. Once we click on that button, the model will predict the recommended career. Okay. So here, after this to call, I can use if Streamlit library dot button. There you can say like predict or whatever you want. Now here the first thing I have to do, since I'm not getting average score from user while using this app, so we have to do it manually. So total score, and for total score I would like to round it like this. So I can use total score divided by 7. I think we have add subject. I'm also going to round it, so it will be average. Average score like this. Now we have to pass all these input variables and these input variables to the function that we have already used in notebook, because that is the function that is used for prediction. Okay, so I can call that function, but first I need to bring that function. So right after import and carrier aspiration, I have added the same function where we have done creating data frame, encoding, scaling, and finally predicted result. So here once we click on the button, we need to call that function and it will get us a prediction. So let me call that function. It's carrier. What was the name? I think it was predict carrier. And let me quickly pause all the variables like gender, part-time, and all those values. So let me remove it and let me pass this code. So as you can see, we have passed to predict carrier all values that we have taken right here, and it will return us the predicted carrier. And here we are going to call success method, and we are printing the prediction. So yeah, that was the development code. So this is quite simple. Once I share all this code, you can explore. So let me refresh. Now let me quickly a male with only 40 score. He has no part-time job with only 30 score, 30 score, 30 score, 30 score, 30 score. I'm going to use lower subject score for this male student. And let's see, that male has no extra activities. He has a lot of absentees, almost 23. No extra study hours, let's say only 2 or maybe 2, yeah. So if we add this, it becomes almost, total score almost becomes, let's say, only 170. So let's predict business owner. Okay, so the model is doing a great job, because as you might have seen and heard in a lot of education or motivational videos, that at the end almost loser wins or backbencher wins. So that's why I added lower values, because the student was backbencher. He has a lot of absentees, no study in weeks, very low score. So finally he will select business, and the model is also saying that business owner.